A very good morning to all of you. मैं Dr. Neha, the convener of this conference. Welcome you all in the second day of International Conference on Bridging Disciplines through Chemical Sciences for a Sustainable Future. The second day we will start with a special session of Professor Mary Garson, who is the Emeritus Professor and the President of International Union of Pure and Applied Chemistry. She has agreed to join our conference in online mode. We are really thankful and we are very happy that such a prestigious personality has now become a part of our international conference. I would like to again extend my heartfelt gratitude and congratulations to Anusandhan National Research Foundation also, whose generous funding support has given us tremendous popularity to organize this conference. Along with heartfelt thank to our other sponsors, Punjab National Bank, Bank of Baroda, Drishti IAS, and Swatantra Education Welfare Society. Now, without wasting much of time, I would like to start the session of Professor Garson. Thank you.
Hello, and good day. My name is Professor Mary Garson, and I live in Brisbane in Australia. And I'm speaking to you in my capacity as the President of the International Union of Pure and Applied Chemistry. Now, if you could just bear with me for a minute while I share my screen with you, because I have some slides that I would like to use for this presentation. And I should go back to the beginning of the talk. So I'm very much enjoying the fact, thank you for the invitation to attend in this virtual way the conference on bringing disciplines through chemical societies for a sustainable future. And I understand that this is an international conference organised by the Department of Chemistry at your university in association with the Association of Chemistry Teachers. Let me just pop this onto full screen for you. Alright, so I'm going to tell you a little bit about some of the interests and activities at IUPAC that are linked to developing a sustainable future. And the first one of those is our networking event called the Global Women's Breakfast, which this year took place on February the 10th and had as its theme, Many Voices, One Science, as you can see from this particular chart. And I need to let you know that the event, although it's organised by IUPAC, is sponsored by a number of organisations: the American Chemical Society, the Royal Society of Chemistry, the Royal Australian Chemical Institute, and by BEO, which is a multinational company, as you know, and by the publisher De Gruyter Brill, with whom IUPAC works. So what is the Global Women's Breakfast and how does it relate to a sustainable future? It's held in support of the United Nations International Day of Women and Girls in Science, which is actually on the 11th of February. Our breakfast was held on the 10th of February because we traditionally hold it on the Tuesday, closer to that international day that, of course, this year is on a Wednesday. And the purpose is to advance the Sustainable Development Goals, number 5, which is on gender equality, and number 10, which is on reducing inequalities. And the objective is to establish and empower a global network to overcome barriers to equality in STEM. And although there's a strong focus on gender, of course, there's also a focus on minorities and those with disabilities to ensure equity and access to STEM as well. So the Global Breakfast was initiated by me, I guess created by me back in 2011 as an event for the International Union of Chemistry. But more importantly, since 2019, when we re-established it in connection with the International Year of the Periodic Table, the wonderful creativity of my American colleague Dr. Laura McConnell, has transformed the breakfast. And as you can see from the map, last year in 2025 we had 448 events in over 77 different countries. The map underneath each of those hearts shows you the origin of the breakfast. And breakfasts start, as you can see, on the right-hand side of the chart in New Zealand, and then they progress around the world through Asia, into Europe, and then into the Americas, and finally they end in Hawaii. So the number and endpoints of events has grown considerably since our very first breakfast, shown in the left-hand side of that graph, when we had about 100 different events, now to over 400. And the breakfast this year, which was held on Tuesday of this past week, we had, I believe, 417 different events in more than 65 different countries. And I think we can also comment that we know that we have more than 30,000 participants every year. So how does this event work, and why does it work? The success and the value of this event is that it's an informal and flexible network that actually plans and runs its own breakfast activity independently. But we encourage interactions between different breakfast groups, contacting each other through social media, or indeed through these online meetings. So in this way, by connecting to other groups, ideas and concepts about breaking down these barriers and advancing equity and STEM can be achieved. So the breakfast is then one of our contributions to addressing the gender gap issue, addressing the barriers to advancement and accomplishment that may impact young people today. And the success, the popularity of these events is linked to the fact that it's taking place in an informal session. As I understand it, there are many chemistry teachers in your audience today, and I think that one of the most important messages that we should be encouraging in the students with whom we work with their undergraduate students or high school students is to ensure that, of course, success in any field is going to be determined by educational and academic background and accomplishments, but also enhanced by other soft skills, emotional intelligence, and the ability to understand the perspective of other people to ensure consensus. In particular, I think that for high school students, the motivation to acquire technical knowledge, scientific skills, and to begin to learn the manipulative and practical skills of science are really of paramount importance. And equally, as well as that, careful planning and preparation for future study roles, hopefully at university, and later contributing to the scientific workforce. I'm going to pivot now to a couple of other activities that IUPAC run that would be of interest to the audience. And first of all, I just want to highlight that we like to acknowledge and celebrate the accomplishment of women in chemistry and the allied discipline of chemical engineering. And so we host every 2 years an award scheme for senior women who have made contributions through research, through teaching, through engagement, and through leadership to the discipline of chemistry. And these awards are presented at our biannual World Chemistry Congress. It would be wonderful to have an awardee, to have nominations coming from India. In the 2023 awards, one of the recipients was an Indian academic, but we would very much encourage also if there could be nominations for 2027. So please do give that some thought. The picture that I'm showing on screen is from the awards ceremony in 2025. You'll see me on the far left of the picture, together with the smiling recipients, and in the middle, the then president of IUPAC, Professor Edward Keenan. Let me pivot now to the other topic that I wanted to tell you about, which is one of our project activities. And it's linked to the vision and mission of IUPAC. The mission of IUPAC is to provide objective scientific expertise and to develop the essential tools for application and communication of chemical knowledge for the benefit of humankind and the world. And this means that the core values of IUPAC in relation to advancing chemistry worldwide are scientific excellence, collaboration and communication, inclusivity, transparency and ethical behaviour. So in July 2025 at the World Chemistry Congress, we officially launched the Guiding Principles for Responsible Chemistry. And this is a website that the link is shown at the bottom, iupac.org/responsible-chemistry. And this is a bold, forward-looking framework designed to transform how chemistry is practiced, taught and perceived worldwide. As you can see, there are 8 topics, 8 individual principles. Top left, responsible innovation. That's got strong links to sustainable development. The second principle covers safety, security and sustainability. The third one covers ethical behaviour. Then we get to inclusivity, equity and belonging. Of course, very strongly linked to those SDGs numbers 5 and 10. Another principle highlights the importance of communication and collaboration. And there is guiding principle number 6, in which I was involved in preparing the content on equitable access. And the final 2, integrity and accuracy and convergence across disciplines, the links to the other scientific disciplines. So what is the purpose of these guiding principles for responsible chemistry? They are more than a code of ethics, a code of conduct. Many individual national chemical societies and other professional organisations will already have codes of conduct and codes of ethics. The guiding principles are a call to action for us, scientists, educators, industry leaders, policymakers, and, importantly, young people, the next generation of chemists, so that we align our work with humanity's most urgent needs. Linked to IUPAC's mission and core values, and developed by a team of chemists from all around the globe over a 2-year period. So the principles actually define what it means to do chemistry responsibly in the 21st century. So of course that means with transparency, with equity, with accountability, and with sustainability. That's the topic of your meeting at its core. So if I could quote one of our...
Over the entire day today, we will explore cutting-edge research, share insights, and forge collaborations that push the boundaries of chemical sciences. So let's dive in and uncover the chemistry that connects us. We have a distinguished panel of experts today to speak on various topics of research. So firstly, I would like to welcome Dr. Aniruddha Balakrishna Patil, who is with us today. Dr. Aniruddha Balakrishna Patil is currently serving as an assistant professor of Maharshi Dayanand College, Parel, Mumbai, affiliated with the University of Mumbai. He has made significant contributions to the field of material sciences and nanotechnology, with a specialization in nanomaterial synthesis, porous materials, biosensor fabrication and applications, catalysis and electrocatalysis. Dr. Patil has published 44 international research papers in high-impact factor journals such as Advanced Materials, Nano-Micro Letters, Advanced Functional Materials, Chemical Engineering Journal, ACS Nano, Biosensors and Bioelectronics, Small Journal of Material Chemistry, ACS Applied Materials materials and interfaces and biomacromolecules. His research has been cited over 2,000 times and he holds an H index of 25. He is the first inventor of 11 patents, including 7 Indian patents and 4 Chinese patents. Additionally, he has authored 8 international book chapters. Dr. Patil completed his PhD from the Institute of Chemical Technology, Mumbai, and pursued postdoctoral research in Xiamen University, China. During his PhD in 2013, he was selected by RWTH Aachen University, Germany for a 6-month research project supported by a prestigious fellowship from Bayer Technology Services. He is the recipient of GRF and SRF fellowships from the Department of Atomic Energy, Government of India. He has also qualified for the NET and GATE examination. His work has been recognized with the 6 Best Paper Awards. At national conferences, he has received numerous accolades, including Young Scientist Award by the Indian Council of Chemists, Young Associate Award by Maharashtra Academy of Sciences, Innovation Excellence Award 2024, Ideal Teacher Award 2024, Best Innovation Award 2025, Best Patent Award 2025. Dr. Patil is actively involved in editorial and advisory roles, Associate Editor Board Member of Current Chinese Sciences, Bentham Science Publications, UAE, Editorial Board in American Journal of Bioscience and Bioengineering, Science Publishing Group, USA, Editorial Board Member of Advanced Science, Material Science and Technology, Omniscient Limited, Singapore, Editorial Board Member of Science Journal of Chemistry, Science Publishing Group, USA, Ambassador of Bentham Science Publication Group, UAE. So I am honored to read out such a brilliant CV of a person, and we have with us today, and he is today going to speak on structural re-engineering of mesocomposite material for sensor applications. We welcome you, sir.
Here I am going to talk about the mesomaterial. So first we must need to understand what is exactly meso is. I hope you all are familiar with the nanostructure. So nano is nothing but 10⁻⁹. When the material goes to the 10⁻⁹, at that level the material is giving something different than that of the bulk. But here in this talk I am going to cover how mesostructure will be responsible as a sensing material. So let's start with what is the structure. So when we are specifically targeting about what is the size, when it is a nano, you can say 10⁻⁹. When it is a micro, you are considering it's a 10⁻⁶. So what is n way to it? So that type of material I am going to target here. So when we are talking about, so my today's talk is mainly focused on the protein material. How that protein material we can use into the commercial one. Because normally whatever materials, protein materials we have, those materials like a wool, sometimes that wool is a waste, but we need to convert that waste into the best. So that's the key point of my today's presentation. So when I am talking about protein structure, then as you are all aware about the protein structure, protein is nothing but a carbon, nitrogen, oxygen, combination of carbon, nitrogen, oxygen, hydrogen. But that beautiful structure you can convert into the aromatized carbon, that is a sp2 carbon. And if you can successfully convert that protein material into the sp2 hybridized carbon, then that means you will get a good conductivity. At the same time, if I am talking about keratin material, in detail I am going to talk on the slide, but when I am talking about keratin material, it is also a protein material, but along with the protein structure, amino acid sequence, we have a thiol, S. So that thiol group I am going to use as a reductant for the nanomaterial synthesis as well as for the encapsulation of nanoparticles. So you can use that keratin material as a reducing as well as a cutting agent for the nanoparticle synthesis, and by using such a materials we can successfully synthesize nanoparticles like a palladium, platinum, gold and all. So while talking about the molecular structure, you can see here it's rich in the amino acid, and this structure you can convert into such a type of structure. If you will see this structure is nothing but sp2 hybridized carbon, also will have nitrogen. If you will consider the structure of nitrogen, then you can consider this group as a ligand also. So there are reports in animals as well as in the rats which report in such a structure as the ligands for the so many reactions. This is the structure which I thought just now spoke. That is this thiol group I am going to use as a reducing as well as cutting agent for the nanomaterial synthesis. Okay, let's start with our target. Here in this work, I have successfully used wool, that is from the sheep, and if you will see the structure of the wool, at a molecular level structure, you will have this type of aromatic, this amino acid sequence along with the thiol group. And then, here the beauty of this work is, when I am going to synthesize nanoparticles, definitely thiol group is going to help me. But at the same time, here is the thiol group. Thiol group I have used for the nanoparticle synthesis. In the same molecule, we have this type of molecular structure of the amino acid. That amino acid structure, after controlled pyrolysis, you can convert into the aromatic structure. So we will get two properties. One is the disulfide cross-linkage, another one is the amino acid structure. Amino acid can be converted into carbon structure, which is sp2 hybridized, and then at one side you will get nanoparticles. So after this, we will have a combination of nanoparticles as well as carbon. Normally in the catalysis, what we are doing in case of enzymatic catalysis and non-enzymatic catalysis. In case of enzymatic catalysis, we are going to use enzymes. But to replace those enzymes, there are so many reports which claims a non-enzymatic material. And what are those non-enzymatic materials? Non-enzymatic materials are nothing but the graphene or the carbon nanotubes. Those graphene and carbon nanotubes are going to decorate by using the gold nanoparticles or the platinum nanoparticles. But in that case, the major issue is catalyst leaching, because you are going to dope nanoparticles on the surface of that material, and the linkage between that surface, that is the carbon substrate, and the nanoparticle is just a van der Waals force of attraction. So your nanoparticles is not going to retain on the structure. So there is a problem of the catalyst leaching, and that's why the performance goes up decreases. But the beauty of this work is, first we are synthesizing nanoparticles, and then that material we are going to carbonize. After carbonize, see here, wool fiber, gold precursor, you will get this type of AU nanoparticles by using thiol group, and you will have this wool keratin structure. Now this is after cooling or the freeze drying. After freeze drying, here is a controlled pyrolysis. What I said? Controlled pyrolysis. 500 degrees Celsius, 700 degrees Celsius, and the 800 degrees Celsius. This is the beauty. 500 degrees Celsius. When I am talking about 500 degrees Celsius material, this material is showing good pH sensing ability. Why this is showing pH sensing ability? That I am going to discuss in a later part. At 700 degrees Celsius, this material is showing good uric acid sensing ability. Why uric acid? Again, that is a question. But why not above 800? That is also the best concern. If I am considering uric acid required sp2 hybridized carbon, because what I am going to do with the uric acid when I am talking about a non-enzymatic sensor, in case of non-enzymatic sensor, my catalyst is playing the role to oxidize uric acid. Here in this reaction, this is uric acid structure. Uric acid molecule is going to oxidize, and whatever electrons are getting released, that electrons is getting released electrons are going to consider in the form of current. How much current is developed? So my catalyst is responsible for this oxidation reaction. Oxidation is nothing but a release of electron, and the release of electron is nothing but going to consider or measure in the form of current. And at the other hand, we have pH sensor. I said at 500 degrees Celsius, my material is a good pH condition, pH sensor activity. So far as our knowledge, this. So here what I said, 500, 700 and 800. At this moment, you just focus on these three figures. What happens exactly? Why not I am going beyond that? Because if you are going for sp2 hybridized carbon, that means you have to carbonize your material beyond 1000. Then why I restricted up to 700 only? Why not 800? The problem is, these gold nanoparticles up to 700 are very dispersed. But at 800, the gold nanoparticles start sintering. So my purpose of this synthesis is going to fail at 800 degrees Celsius. That's why I limited my synthesis up to 700 only. Now in this case, when I am talking about 500 and the 700, so the assumption or the science is explained by PM and SM images. You can see here up to 700 degrees Celsius, your gold nanoparticles are in the spherical shape, but at 800 it starts agglomerating. This is the effect of the high temperature sintering. Also, what is the effect of temperature on the carbon? So if you are moving from 400 to 800, this graphitization goes on increasing. That indicates my material is going toward the sp2 hybridized carbon. Okay, when I am talking about how much area I am getting, so the beautiful observation is at 700 my area is topmost, but again at 800 the area goes on decreasing. From 400 it consistently goes on increasing. What is the reason behind it? The reason is when I am pyrolyzing amino acid, there is if I am considering amino acid, that means it is having COOH group as well as NH2. When we are burning or when we are heating it, the COOH, that is a carboxylic acid group, is converting and evolving in the form of CO2. Also the amino acid amine structure NH2 is getting evolved in the form of ammonia. So the gases starts evolving. So my structure is converting into the porous material, and that's why my surface is increases consistently. Then what is the reason why 800 degrees Celsius is dropped down? It is because of the breaking of the structure. These reports are supported by the XRD as well as the Raman, and the Raman clearly indicates that when we are going to increase the temperature of carbonization, my sp2 hybridized carbon is going on increasing. Now, as I already told you, we are quite familiar with the glass electrode, which we are using for the pH sensing. But to replace the glass electrode, or when I am targeting the biomolecules like the sweat, saliva, your tears, so the quantity of tears is not in the beaker. You cannot take the PS in 50 ml PS. You don't have that provision. You don't have the sweater, 100 ml sweat. You don't have a 50 ml of saliva to measure and to use a glass electrode. So, to measure the pH of the body fluids, there is an invention, and that invention is a strip-based pH sensor. When I am talking about a strip-based pH sensor, the material, the solid catalytic material, is mainly associated with this polyaniline structure. This is what? Polyaniline. The mechanism is protonation and deprotonation. Simple protonation, deprotonation. Now, when I am using my chemistry or the material which I have carbonized at particular temperature, in that case, if you will see here, in this case, the percentage of carbon is a 47.89 and the percentage of nitrogen is around 9%. So 9, 6 are 54. That means after 6 carbons, there is a possibility of 1 nitrogen. It means after 6 carbon, possibility of 1 nitrogen. After 6 carbon, possibility of 1 nitrogen. So this is nothing but dynamic structure. So when I am speculating my structure, so my structure is somewhat like this. And in this structure, 6 carbon, nitrogen, 6 carbon, nitrogen, 6 carbon, nitrogen. So this may be the structure, and that's why my material is giving the best pH sensitivity at this temperature. And that's the beauty of this one. First time we are claiming that, yes, we have replacement for polyaniline. Definitely not that much effective, but yes, this is our first try. And we proved that yes, my material which I have carbonized at 500 degrees Celsius showing the best pH sensitivity. Now, this is the process of fabrication of 2 electrode sensor. At 500, the material which carbonized at 500, I am getting good pH sensitivity. Then why the material which I have carbonized at 800 giving me a less pH sensitivity? What is the reason? The reason is, as the temperature goes on increasing, nitrogen in the form of ammonia is getting evolved. So as nitrogen is getting evolved, the percentage of nitrogen which I am claiming after 6 carbon 1 nitrogen, that is going to drop down. So my aniline structure which I am speculating in my carbonized material is going to break. That's why my material is not good for pH sensitivity at a 500 degrees Celsius. These are the reports which showing that how my prepared sensor is useful for the measurement of different sweat sample as well as urine sample. Here we investigated, we took the sweat sample of different volunteers as well as the urine sample of different volunteers, and we found that the pH meter, like commercial pH meter, whatever the result obtained, we got also the same or the equivalent result by using our material. Now come to the uric acid sensor. While talking about the uric acid sensor, as I already told you, here I need different properties than that of the properties which are required for the pH sensing. Because in pH sensing, my target was aniline, to mimic the aniline structure. But here the idea is completely different, because here I am going to oxidize my uric acid molecule. So, for this oxidation, my catalyst should be a good conductor. To get this conductivity, I have 2 beautiful features here. One is my material, as I already mentioned, you will get you are increasing the temperature of carbonization, your sp2 carbon percentage goes on increasing. That means I have sp2 carbon. Also, I have gold nanoparticles which are well dispersed. So, along with the sp2 carbon with the gold, I am getting a material which is a good electrical conductive. And by using such a material, we fabricated 3 electrode sensor, and by using this, we got a good result. When we compare our result with the commercially available uric acid sensors, our results are somewhat very close. to the commercially available electrode. And that's why here are the results. We compare our results with the reported results and we found our results are also the best results. We compare uric acid sensor with our results. There is a linear response between our results with the commercially available uric acid meters. So this is the beauty of this work. In this case, in this work, I started with the wool keratin. My structure is amino acid and thiol group. Thiol group I have used for the gold nanoparticle synthesis, and the amino acid I am going to convert into the carbon structure. At 500 I am getting a structure which mimics AB polymeric structure, that is a polyaniline structure. So this material is good for pH sensitivity, and at high temperature carbonization, my material is having sp2 hybridized carbon with a well dispersed gold nanoparticle. So this material is good for the uric acid sensor. Now coming to the next point, in this case, another protein molecule, that is the silkworm protein. The silk sarees, as you all are wearing. Now the beauty of this work is, in this case, at molecular level when we are going, we have same structure of this beta crystallite. This beta crystallite is nothing but it is a sequence of the amino acid. And now here we have provision. If we are pulling forcefully, then the alignment of beta crystallite is in the parallel form. So I am getting orderly aligned, that is a fiber, the saree which you are wearing. And if I am keeping that material for the random development, I can get a film or scaffold or gel, like your egg protein. So in this case, if I am using this silk, now I have a chance to dope that silk material at a beta crystallite level with some dopant. So here I am going to use carbon nanotubes. Why? Because carbon nanotubes are good electrical conductor. And if I can incorporate carbon nanotubes in your saree thread, so your saree is also creating a light. And that's the idea behind this work. So this is the performance, this is the method by using which, if I am just making a thread from this crystallized structure, I am getting such a type of thread. But if I am putting carbon nanotubes, I am getting such a type of fiber. And here we are using wet spinning method for the preparation. These are the reports which supports our chemistry, that when we are increasing the concentration of carbon nanotubes, this is the structure what we are speculating, the carbon nanotubes with this beta crystallite, and these are some analytical results. These are the SEM images, AFM images, then fluorescent images showing that percentage of carbon nanotubes. Now, this is a very interesting point. Here, up to 30, my electrical conductivity is increasing gradually. But at 35, it increases tremendously high. The reason is, up to 30% doping, my material or the CNT concentration may be reaching to the optimum. But at this point, all our CNTs are now overlapped with each other. Initially, my CNT may be randomly arranged, but at 35, CNTs may be like this. So automatically the channel for the conductivity is perfect, and that's why I am getting a good electrical conductivity. You can use such a material for the moisture sensor as well as for the pressure sensor. And on this, we filed the Indian patent, and during COVID only, we filed a patent. The idea was, in N95 mask, we kept that thread, which is an electrically conducting thread, and when the patient or the wearer using that mask, because of the moisture content coming from the inhale and exhale, the percentage of moisture going increasing as well as up and down. So we are getting fixed like this. This is a mask which we prepared in China. But in China, this mask is up to only respiration. But here during COVID time, what is our idea? Along with this moisture sensor, we get one temperature sensor. So as and when wearer use this mask, immediately his doctor will get the idea about the patient, about his moisture, breathing rate as well as temperature. The another beauty of that patent is, since we are putting two sensors in the mask, the cost of the mask is very high. Now, so you cannot throw that mask every time. So how to recycle that mask? You cannot go for washing also because the sensors are fitted in that. So what to do? So there we use, I took a help from the physicist and we implanted one coil in that. So the coil will work as an iron. So the temperature we raise up to 65. So that temperature is enough for the sterilization of the mask. So the wearer can reuse that mask. That was the idea. So these are some videos how the fiber which prepared by silk and the CLT is good. I can't play this. You can play these videos. Can you?
Playing of video is possible.
Is it possible to play the videos?
I think the play mode should be applied. Play mode. Play mode over. Not top play. Start.
दो बार प्ले हुआ
Auto play. Auto play is there.
ये वीडियो है. All are videos.
Auto play नहीं करता है.
हाँ वही तो.
Auto play हाँ. Nice. Yes.
Yeah. See, even this type of pressure also can be measured.
Go back. Nice.
The thread is electrically conducting. And this is a mask. When I put this spray inside the mask, so this spray is working as a humidity sensor. So, thank you so much for your patient listening. Thank you.
So I would now like to call upon, as our principal ma'am has joined us, I would like to call upon our dean principal to felicitate sir with a bunch of memoirs from the college.
Thank you so much.
By the University of Johannesburg, focused on studies on trans-acidification of fatty acids
This
for
meeting is
production
being
of
recorded.
high-quality biodiesel by magnetic impulse high-frequency cavitation processing on activated carbon hydrotalcide support. Ajay Bisweshwar serves as a head mentor of South African Chemistry Olympiad team to the International Chemistry Olympiad and the International Junior Science Olympiad. Dr. Viseshwar Ganesh was certificate the following areas of analytical, applied and industrial chemistry, acid bisulfite processing of eucalyptus and Pinus spatula species of dissolving pulp and manufacture of rayon viscose, insulating craft and oils used in transformers. Currently, his research focus is on insulating oils and materials, surfactants and waste oil analysis, as well as desalinization and water research. We welcome you, sir. He is going to speak on the topic rejuvenation of cellulose-based insulating paper used in high voltage power transformers.
I think many of you know South Africa is a cricket-loving nation. Also, we are the world champions in rugby and so forth. So here, if you look at the map at the bottom, you will see basically the city of Durban right on the east coast. A little dot, that's the city where we come from. Interestingly, Durban has the highest number of Indians outside India. We have a beautiful coastline. You can see the Moses Mabhida Stadium. We have beautiful hotels. We don't have a winter in Durban. Generally, the temperatures in winter go down to a minimum of about 10 degrees sometimes, but very rarely. So at the moment, we're in the midst of summer, and it's quite hot. We're looking at temperatures of 36 with high humidities. There's a beautiful temple. It's the Hare Krishna temple that we have. So we have a lot of temples here in South Africa, having quite a large number of Hindus. We practice our religion very proudly. The picture at the bottom is an old picture I share with you of a few years ago, maybe a picture from about 30 years ago. And this was a street scene in South Africa, which is called Grey Street. It was mainly for Indians, because during the apartheid system, we couldn't go into the streets that were for the white population. So here's a street scene of Grey Street, and many Indian businessmen lent their trade here in Grey Street. I'm having some issues trying to get to my next slide, so if you just bear with me. Apologies. Sorry, I think I'll just use the mouse. Okay, so this is me, and I have been introduced by the speaker. My research interest, if you look at my applications of research, being an analytical industrial chemist, I've actually collaborated across the board, and hoping to work with some of you in the near future. These are some nice pictures of our undergraduate teaching laboratories. We have very good world-class facilities at UKZN. I must also add that we have a large number of students from India that are currently masters and PhD and postdoctoral. We have in excess of about 30 to 40 students studying at our university, coming from Amritsar in Punjab, from Mumbai, Delhi, and all places. So we have quite a large interest in our department. So the background to my work is basically based on transformers, and in South Africa we've been having issues as far as transformer fouling is concerned. So the thrust of this research was looking at transformer insulation, which you see a typical transformer in figure 1. And it's basically it's made up of insulating paper, or comprised of insulating paper. So you have the copper windings, and we have insulating paper, which is cellulose based. So you can see the windings in figure 1. That's basically the copper windings are covered in insulating paper, and this whole contraption is then steeped in oil. So in figure 3, you look at transformer oils, and I've just given you an idea of when we age it. In A, you can see virgin transformer oil, which is unaged. In B, you can see it's aged for 5 days. And then you can see in C, you can see transformer oil at 160 degrees, okay? The B was actually over 2 days, not 5 days. It's just an error. So it was basically over 2 days. You can see the browning of the oil, which means oxidation. So insulating paper and oil have limited useful and effective lifespan due to the accelerated aging. So I'm going to focus on the insulating paper. Fouling ultimately leads to failure of the transformer. So over a period of time, the insulating paper is steeped in oil. So there's huge chemistry involved. And if you look at figure 2, your cellulose polymeric structure is basically a kraft insulating cellulose that's used here in South Africa and manufactured here. So we have large quantities of contaminated insulating paper that accumulates, and it's difficult to dispose because, remember, the paper that's basically wrapped around the copper windings becomes soiled with the oil that you see in figure 3, and it's obviously the brown oil. So it becomes an environmental hazard. So currently, there's no cost-effective method for what we call the recycling, and we want to call it the rejuvenation because we want to reuse this particular solid insulation that we have. So the research that I embarked on with a master's project was to investigate the rejuvenation of aged cellulose-based insulating paper using chemical and biological bleaching techniques. And I'll talk about this in detail just now. So we looked at restoring through chemical and bio-bleaching the physical and chemical parameters that renders it effective as an insulator once again. So we want to take the used insulating paper, we want to chemically and biologically bleach it. So we looked at the two techniques and we want to restore it to its effective insulating property. We also, under this research, want to understand the main chemical and physical parameters of rejuvenated insulating paper. So I will show you just now how we have virgin insulating paper that has good qualities. So then we wanted to identify the main chemical and physical parameters once we've rejuvenated this paper. So we embarked on our specific objectives, basically looking at aged kraft cellulose. Basically, kraft cellulose is a kraft process that's used here in South Africa, where trees, that's basically pulp, we're using sodium sulfide and sodium hydroxide, and then it just goes through a bleaching process, which is essentially called the kraft process. The other alternative methods are acid sulfide and acid bisulfide processes, but those are applied mainly to producing dissolved pulp that goes into making pure cellulose above 95%. So we looked at kraft cellulose paper by a chemical method using two different types of bleaching agents and biological bleaching. So we looked at chemical bleaching and biological bleaching, and we've identified a strain called Acinetobacter B2, and I'll explain how we arrived at using this particular strain. So we also wanted to study the chemical properties that will be assessed. So obviously looking at the alpha cellulose content of the paper, the viscosity, which is an important parameter that tells us something about the degree of polymerization, and obviously the two perforaldehyde content, which are the furanic content because when we look at the degradation of paper, it normally produces 2-fal, or what we refer to as 2-perforaldehyde. We also investigated physical properties. As you know, paper is important in terms of tensile strength, stretch, and the TA, or what we refer to as tensile energy absorption. We also did a bit of electron microscopy work to identify the morphology, and we identified the crystallinity of the solid insulation by X-ray diffraction, and I'll share some of that. So my next slide basically shows you the breakdown of cellulose, and as you know, insulating paper contains cellulose, which is a polymeric chain of monomeric units. If you look at the cellobiose unit, it polymerizes and it alternates at a 360, 180 stereochemistry. It rotates at 180 degrees to give you basically cellulose. So as cellulose ages, the cleavage of the polymer, the chain end reduction, and you have a reduction in degree of polymerization. So in figures 4 and 5, this work was actually done by Unsworth and Mitchell and shows you the breakdown by heat when exposed to oxygen, water, or acid, and you can see the formation of the two foul oils. I just want to explain a little bit about transformer oils, and here we can see on my extreme left, the colorless is basically transformer oil. So transformer oil usually is a naphthalene-based oil, and it's part of the insulating system. And as I showed you in the previous picture, you saw the copper windings that's wrapped with the cellulose paper, and that so it's found in the windings of the transformer body. The fundamental role of the transformer oil is to cool, insulate, and last the lifetime of the transformer. So when the copper windings are basically wrapped with cellulose paper, then it's steeped into this oil to obviously keep the transformer cool. Remember, we don't want to lose heat to the surroundings, and we don't want to use efficiency of the electricity generated. So transformer oil is usually naphthalenic based, as I said. They have low viscosities, and it makes it a very efficient compared to paraffinic based oils that was previously used, because the transformer oil impregnates the kraft paper faster, and it minimizes the presence of air bubbles, and in this way provides effective cooling at higher temperatures. But the problem is that as the oil ages and degrades over a long period of time, the color of the oil becomes brown, and this picture very nicely shows. So the next slide, I talk a little bit about the degree of polymerization of solid kraft insulating paper. And here I just want to show you in terms of the degree of polymerization, which is the average number of glucose monomers per chain, is generally 1,200 for excellent quality of new kraft paper. So we benchmark the DP as 1,200. And as you can see, as it ages, most of the DP values range between 200 and 600. So you can find that for DP values ranging between 610 and 900, we say that the paper has undergone minimal to mild aging. So you can see in terms of the DP, it gives us an idea of where this paper is and at what extent of degradation it's currently going. So DP values lower than 610, the paper sustains minimal deterioration. However, DP values between 460 to 360 is significant deterioration. This work is well documented, so we use it as part of our studies as well. I just want to talk about the chemical bleaching, and here it's simply, we looked at sodium hypochlorite and hydrogen peroxide. I'm not going to go into too much of detail, but simply sodium hypochlorite is an inexpensive delignifying and moderate oxidizing agent, okay? It breaks the lignin bonds. In terms of hydrogen peroxide, you find that we are able to carry out brightening of the pulp, okay? And also, in its peroxide is often used at the end of a conventional bleaching sequence to prevent the pulp from losing brightness over time. So it's an effective technique that is inexpensive, and obviously peroxide is a less harmful component to sodium hypochlorite. And then we sort of logged into this bio-bleaching, and Coma et al. In 2001 identified the Enterobacter strain to biodegrade long paraffinic chains, okay? And so you can see in this figure 8, he basically degraded oil, car oil, and the N-hexadecane was fed as a substrate, and the intermediates that were detected were 1-hexadecanol and decanoic acid. So GCMS analysis showed that this basically provided a terminal oxidation pathway of alkanes. So hence the idea of bio-bleaching using this Akinito factor was born in our research. The experimental, I just want to take you quickly through it, was basically preparation of the chemical bleaching agents where we looked at hypochlorite. We chose arbitrarily a range of 0.3% to 1.8%. The preparation of the bio-bleaching bacterium culture, this was actually carried out in the School of Microbiology under the guidance of Professor Johnson Lin that I collaborated with. And then we prepared preparation of the aged solid kraft insulation. So what we basically did was, we took what we call virgin kraft insulation paper and we steeped it in transformer oil at 160 to 160 degrees over 5 days. So in other words, we sort of had this aged kraft paper and we created a scenario of aged kraft. The determination of alpha cellulose and viscosity was carried out according to very well-known documented tapping methods, and the viscosity of pulp by the capillary viscometer method. Quantification of 2-fel using HPLC, these are well documented and well known. The analysis of tensile strength stretch and was not done in our labs. We actually contacted a company called SAPI here in South Africa, and they assisted us with the tensile strength stretch and the tensile energy absorption. We also looked at the determination of the crystallinity by powder X-ray diffraction. So I'll move on straight on to the results and discussion. But obviously we looked at crystallinity and then obviously the surface imaging by scanning electron microscope was done at our electron microscope unit. So in terms of the resulting discussion, in table 1, what I want to show you virgin kraft insulation paper. So we sort of looked at virgin kraft insulation paper and looked at the alpha cellulose because the degree of polymerization and the viscosity relies solely on this alpha cellulose content. And as you can see, the degree of polymerization was basically recorded to be about 1,338, which tells you that the virgin kraft insulating paper is of a good stability. Cellulose, okay, there's an increase in the alpha cellulose content with both hypochlorite and the kraft. So we're starting off at about 7% of aged kraft insulation, and the alpha cellulose increases. Now it's a bit of a paradoxical state because we age the cellulose, but how does the alpha cellulose increase? And I'll explain that just now. The viscosity drops, which is normal, and the DP also drops, which is expected. Right at the bottom you'll see I have bio-bleached. And here again you can see alpha cellulose increases and the kinematic viscosity doesn't decrease to a very large extent. And you can see it also holds its threshold, that means it doesn't go below the threshold of 610 in terms of the DP. So the main objectives of chemical and bio-bleaching was to restore the aged kraft insulation paper close to its original insulating property. But obviously we can't increase the DP, you can't get it because the chains have already been broken. And we increased the hypochlorite and peroxide to increase the alpha cellulose content. Now I did say to you that we're seeing an increase of the alpha cellulose content. But that's because of the result of the oxidation and the removal of degraded products. So in other words, when we took the aged kraft insulation, we oxidized the degradation products, and we now are left behind with alpha cellulose. So we wanted to, so hence we looked at the alpha, so a 5% increase that you see at 85.9, 81.8, that's obviously based on the 65%. If I can just take you back. If you look at AKIP, there's 64.7%. In other words, we've got rid of the degraded products, and we now showing that we have, we are only left with this alpha cellulose because we've removed and oxidized some of the degraded products. So again, we note the DP drops 595, 570, okay, at bleaching strength, so that is normal. The bio-bleaching showed the highest alpha cellulose, and the threshold DP for effective insulation was held extreme. Okay, this figure simply shows you the trend. Okay, increasing alpha cellulose, decreasing DP with hypochlorite, which we refer to as chemical bleaching. Then the impact of chemical and bio-bleaching on alpha cellulose, degree of polymerization, and tensile strength. In table 3, I simply want to show you in terms of the virgin kraft insulation paper. Again, according to literature, we see above 90% alpha cellulose, and if you look at the aged kraft insulation, we get 66.7 in terms of the alpha cellulose, and then you can see the degree of polymerization has dropped. I am showing you the physical strengths, the physical parameters of tensile strength, stretch, and the tensile energy absorption. So again, here you can see decreases. Okay. So with the age, there are obviously decreases with tensile strength, stretch, and the tensile energy absorption. So you can see that despite there's a decrease in tensile strength, stretch, the minimal levels are not below the threshold limits for its end of life as an insulating paper. I want to indicate that means while there's a decrease in alpha cellulose, while there's a decrease in the degree of polymerization, tensile strength, stretch, and the tensile energy absorption, kraft insulation paper can still carry out its insulation properties at these levels. So it's not in a bad state, it's not in a critical state as such. Okay, so if I look at the chemical and physical parameters of rejuvenated in table 4, so what we're showing here is now we've taken the aged kraft insulation paper and we have basically exposed it to chemical bleaching, again, as you would see, A, B, and C. And here we've chosen, in terms of A, B, and C, we've chosen 1.2% of hypochlorite and peroxide concentrations, 1.5 and 1.8. And this was basically born out of the previous, the previous experiments where we found that this would give us the best chemical bleaching effects. What you need to note in table 4 is the bio-bleaching D actually gives us very high alpha cellulose. It gives us again a good degree of polymerization. The tensile strength, the stretch, and the tensile energy absorption are all well above the threshold. Okay, so you can see that in this kind of work, the bio-bleaching seems to be coming out as an effective, or if not, basically doing its job in rejuvenating this paper. So previous scientists have benchmarked insulating paper that has reached 50% of its original tensile strength to undergo severe degradation. So remember I said that we're looking at chemical and physical parameters. This is, in insulating paper, insulating oil, there are so many parameters to deal with. But sometimes we look at the sort of main parameters that we could deal with. And in this case, for example, tensile strength becomes an important parameter. And hence we can see here, for the chemical bleaching, the tensile strengths have decreased quite a bit. But in terms of bio-bleaching, it's held its value at a very high value. And that is a sort of a marker, a flag to say that the bio-bleaching can work. Okay? So bio-bleaching, the lowest change in tensile strength, stretch, relative to bleaching, as you can see, I've shown that in table 4 highlighted in red. So biological bleaching produced rejuvenated, which I call it rated, aged craft insulating paper with the least negative physical and chemical alteration. Okay? And again, the change in tensile strength and stretch as a measure of thermal aging, chemical and biological bleaching. So I'm showing you basically again, if you look at the change, so table 5 is just showing the change. And just to highlight at the bottom, you can see in table 5 that the bio-bleaching has undergone the least changes in terms of your tensile strength, stretch, and your tensile energy absorption. In table 6, basically what we did was we looked at the mass balance of material, and when we looked at percentage of material loss, remember you're oxidizing. So again, D highlighted in red in table 6 simply shows you percentage of the original paper remaining of the 8 craft insulation paper and the percentage of material lost. We quantified the 2 high performance liquid chromatography, HPLC, and again here you can see virgin craft insulation paper comparison when we age it. Obviously there's a loss in tensile strength, and you can see the increase in the 2 Okay, so there is an inverse proportionality between true film and the tensile strength. So in table 8, we basically showed this. Again, I just want to highlight in table 8, with chemical bleaching versus bio bleaching, we have basically a true film of 12.54 ppm compared to very high true film, which means that you've got higher degradation of the cellulose or the cellulose units to give you the furanic acid components. And again, the tensile strength holding its value to give us a good quality. We looked at the crystallinity index, and in terms of our crystallinity index, again, I don't want to take you through too much of the discussions, but here we see that the bio-bleaching showed a higher crystallinity index. And basically, crystallinity index, I know many of you are experts in this, highlights changes of the morphology of the cellulose which occur during bleaching. So, to a certain extent, the bio-bleaching has not disrupted the morphology of the paper, and there still has to be quite a lot of work done in this. I didn't delve too much into this kind of work. And when we measured the crystallinity index, again, you can see bio-bleach coming out the top at the bottom, shown in table 9. And finally, when we looked at surfacing image, so we tried to delve into SEM, and you know it's always a difficult scenario to look at SEM images. But here simply what we were seeing is that the crystallinity, rigidity, and flexibility are the key properties of fiber morphology. And when you look at the pivotal role it plays to function as an insulating effective material, but what happens during aging and bleaching? You get an alteration of the structure of the fiber, and a flattening effect of the flutings was observed for the aged craft insulation paper. And so if you look at the images, A is virgin craft, okay, so A at the top here, you can see B is aged, so in B you can see the flattening effect. C is bio-bleached. Image D, okay, you can see, so you can see image D again has a flattening effect, and basically with the peroxide, there's not so much of flattening, but hypochlorite and thermal aging basically shows that flattening effect. So from the images, the raised flutings and chopped furrows were clearly visible as a result of the thermal processing to achieve the creep effect. In other words, we have what we call thermally upgraded paper, and you can see the flutings, or what we refer to as the flutings and chopped furrows, that basically was thermally processed to what they refer to as crepe effect, to enhance the thermal stability of paper. But just to show you that you get the flattening when you age this particular paper. So in terms of the conclusions, chemical and bio-bleaching was successful and effective in treating accelerated aged virgin craft insulation paper. Chemical bleaching works at certain bleaching strengths, bio-bleaching using the Acinetobacter strain to prove to be the best suited rejuvenation technique, since it generated the highest percentage alpha cellulose and obviously gave us acceptable degree of polymerization. The chemical bleaching techniques require careful and controlled cleanup treatments as they are chlorine and hydrogen peroxide-based reagents, while bio-bleaching is an extremely eco-friendly technique. And I've just listed the optimum conditions that were attained. And finally, the 2,4-aldehyde is an important marker in identifying degradation of the virgin craft insulation paper. So I would like to pass my acknowledgements to the School of Agriculture and Science here at the University of KwaZulu-Natal, the ESCOM Tertiary Education Support Fund, the NRF, my PhD student Dr. Yashmika Jion, our lab technician Ms. Anita Naidu and Ms. Unati Bongoza, and my colleague from Johnson Lynn School of Microbiology. I would also like to thank the organizers of the International Conference on Bridging Disciplines with Chemical Sciences for a Sustainable Future, Prof. Amrit Mitra and Dr. Neha Rao for extending an invite and for the information shared, and to all your delegates and participants for your attendance and participation. Thank you very much. Thank you. Are there any questions?
Any questions from the previous expert? Viseshwar sir, Ajay Viseshwar sir, any questions from the audience? Sir, no questions. Thank you so much, sir.
Thank you very much. Have a good day.
Thank you, sir. I continue with Dr. introduction. He has more than 90 research papers in various refereed international and national journals of repute. He has given research guidance to 21 PhD students. 6 students are still registered and working actively under him. He is the IUPAC member, INSA nominated affiliate membership of IUPAC UNESCO 2012-2013. He has coordinated more than 150 chemistry popularization workshops for students and teachers across India, Abu Dhabi, Dubai, Sharjah, and Doha. He is the panel member for National Level Best Chemistry Teachers Award instituted by Association of Chemistry Teachers and Tata Chemicals. His research interests are advanced oxidation processes, photocatalytic degradation of organic pollutants such as pesticides, dyes using UV and visible light, green chemistry and sustainable science. He has been engaged in doing extensive work on training programs for learning and teaching creativity using various models. Students at every level need a creative and flexible mind for learning and integrating new knowledge. So he has been cultivating.
I am audible.
Yes, sir. Yes, you
No,
are.
I
You
can.
are.
Yeah, now you are audible. Yeah. Okay.
So he has been cultivating young learners' creative capacity in order to develop their for study, work, and personal life. He is working on methods of teaching and learning phenomenon-based learning. His topic of interest are atomic structure, organic reaction mechanics, chemical kinetics, quantum mechanics, thermodynamics, green chemistry, spectroscopy, etc. As a research person in various literature and orientation courses for teachers. He is the referee for referral Journal of Physical Chemistry published by American Chemical Society USA, International Journal of Colloids and Surfaces published and the Enzyme of Science from New Zealand, International Journal of Chemical Kinetics published by Ministry from USA, Science Education Education in Australia, Chemistry Americans and Australia, European Journal of Chemistry and International Journal of Ethiopia, Journal of Hazardous Materials and Xylers UK, Indian Journal of Chemistry Kolkata, South African Journal of Chemistry, South Africa. He is membership of Chemical Associations. He is the president of Association of Chemistry Teachers during the period 2020-2024. He is a vice member of Chemical Research Society of India, Indian Institute of Science, Bangalore. He is the vice member of the Indian Council of Chemists, Andhra. He has been awarded postdoctoral fellow of the National Research Foundation Victoria, South Africa for 1 year, 1999 to May 2001 at University of Durban, West Durban. I received nomination for fellowship ICBDCSSF 2012. Today he is sharing his research in sustainability circular chemistry. He welcomes himself.
Thank you, madam. I'm audible?
Yes, sir.
Okay, and I have shared it. My presentation is there.
Yes.
It is visible. Okay. You just let me start. Nobody got stopped. Sorry. Yeah. Okay. Thank you so much. And good morning, the principal, Kanya Mahavidyalaya, Lucknow, Dr. Neha Agrawal, the organizer, the convener of the program, the Professor Givangada from University of Durban, Westville, University of Coastal Natal. He is attending the program, my teacher. Then Professor Ramesh Shankar, and all the organizing members of this wonderful national conference. So, thank you for giving this opportunity, and I have been given a sufficient time to speak on circular chemistry. I'm these days, we are all talking about sustainable development, and Dr. Neha has really chosen a very apt title for it, and this is really a time, among the chemists to talk about how we can contribute for sustainable development. We are all aware of the 17 sustainable goals everywhere we are talking about, and what is the role of chemistry to have a sustainable development on the planet. So just one thing, I used to say, Alicia, like spending beyond income, makes us bankrupt. So consuming endlessly on the finite earth can make us suffer miserably. That is what is happening, because we have exploited our earth to a very huge extent. What has been doing for the last so many years, immediately after the Industrial Revolution, like we are taking resources, extraction is done, things are manufactured, goods are manufactured, distributions have been carried out, consumption is done, and after the use, there is a particular goods or material has been thrown to the landfill, and that is a kind of a waste. So this is a very linear approach, all we have been doing so far. But now the time has come, that the role of chemistry has to come on the fore, and lot of work has been done, across the globe. So the circular chemistry is very important thing, and just by expanding the scope of the sustainability to the entire life cycle of chemical products, the concept of circular chemistry aims to replace today's this linear, what just I have spoken, take, make and dispose approach with the circular process. That we need to learn from the nature. And this will optimize resource efficiency across chemical value chain and enable a closed loop, waste-free chemical industry just to save the planet. Yeah, this is I have spoken. So now everything is really very important. Just to know the finite nature of the resources, including the element scarcity. We understand so much of lithium, so much of elements we are using, it is flowing to the landfill, and it's really to and as well as the limited environmental tolerance towards our chemical industry has grown tremendously in the past few decades. So now the time has come to us to contemplate it and what more can be done and what different can be done. So circular chemistry has really come to rescue for this. It's very painfully obvious that the linear route of production, in which the most of the precious and the important is gas, limited resources are consumed and their value-added products are degraded to waste. Okay, and that is the root cause of several impending global crises. We talk about climate change, diminished biodiversity, as well as food, water, and energy shortage. So this is the source, this is the root cause of all these kind of problems we are facing. And this is just one, like you might have seen, during this, the periodic table, the kind of, the elements diminishing, and that is a one-time resource, we cannot have it, again. So now the circular, to attain a sustainable development, circular economy is very important. So what is the circular economy? Circular economy is restorative and regenerative by design and aim to keep products, components, and the materials at their highest utility and value at all times. Highest utility and value at all times. That is the definition of circular economy. And chemistry is crucial for achieving this. Here comes the role of chemistry in order to enable circular economy, thereby saving the planet, thereby attaining the sustainable goals. Just brief, about what is the restorative and regenerative design. So the restorative and regenerative design focuses on creating systems that are not only minimize harm to the environment, but actively restore and enhance ecological health. That is a wonderful thing. Not only we are minimizing the environmental health just by having this circular economy, but we can restore the ecological health of our planet. And again, the role of chemists. The chemists understand their role in designing and developing indispensable materials and technologies, but also simultaneously recognize the potentially detrimental effects. Chemists are aware that each step must be designed and reassessed with sustainability in mind. That is very important. Lots of things are happening, lots of new materials are coming, lot of new technologies are coming, but now the time has come that we have to think beyond the green. Even if the process is green, it has to be tested whether it is sustainable or not. I will give you a few examples of that. So green chemistry last 25-30 years have been practicing. We all know about the 12 guiding principles of green chemistry. They focus on the direct sustainability assessment of the chemical reactions and are perfectly suited for the optimization of linear production routes. Okay, that is fine. Green chemistry has contributed enormously for optimization of linear production. The developments towards a circular economy, however, require a re-evaluation of what defines a sustainable chemical process and needs to take into account three things: the people, the planet, and the profit. These three criteria has to meet, in order to prove that the process is sustainable or not. Usually it is called a triple bottom line. We probably all aware of it. So innovative chemistry design with sustainability in mind is only effective when translated into economically viable applications. Because see, the growth, the development cannot be denied. We have to go ahead. The society has to go forward. We need to synthesize new material every day. The technology has to improvise, but every time, for every kind of reaction, the chemist does, any kind of the invention or innovation is done, these three things have to be taken into mind: the people, the planet, and the profit. I will give some examples. So the chemistry of sustainability, or you call a sustainable chemistry, that recognizes that sustainability without innovation is impossible, and innovation without sustainability would be ruinous. So this is a punchline, that is really in order to have a sustainable world. These are the 12 principles of green chemistry. I am not going into the details. We, even at every level, even undergraduate and postgraduate level, we have all just gone through it a number of times. But I'm not going to read out all these things. I will just give you, we'll go towards the sustainability. Green synthesis of adipic acid, for example, so which is a key component of the manufacture for nylon 66, and it is done by the direct oxidation of cyclohexene with hydrogen peroxide. Okay. Now this reaction, that is cyclohexene and hydrogen peroxide, is a solvent-free conditions because nitric acid is not being utilized here, and thereby the environmentally taxing gas like nitrous oxide doesn't come into play. So it's a green method. But and it requires hydrogen peroxide, which is a green oxidant. It's a starting material. So this whole thing, that this reaction is a green reaction, it is a green method. Now, the problem with this, that the hydrogen peroxide is more expensive than the adipic acid, which is a product. You're getting my point. So now this is not commercially industrially viable because it doesn't fit to that PPP, the planet, people and profit. Yeah. So although this route obeys the green chemistry, but it violates the value chain. So as a result, this green adipic acid synthesis has not been applied industrially and therefore not led to an overall increase in the sustainability. So every time, this is one example where there is a need of accounting the profit level of that triple bottom line is very essential. One more example let us have, which we all know, that is the Haber-Bosch process. And this is an example of green chemistry principles, where it is economically viable, okay, but still not sustainable. Why? Because see, here what is happening, iron is being used as a catalyst, nitrogen and hydrogen making ammonia, which in turn used for the production of agriculture fertilizers. It is a key industry showcase for the use of catalysts because iron is being used in increasing energy efficiency. The current process requires high temperature and pressure, and further optimization has stagnated. Okay. Moreover, despite being a catalyst is used, okay, it is economically viable, but it is a problematic thing. See, what is happening? Eutrophication. After the use as a fertilizer, large portion of the fixed nitrogen, they are lost to the environment, causing eutrophication. It's a global environmental concern, and the importance of it should not be underestimated. So an increase in water and air pollution, both of which threatens to destabilize the Earth system beyond the proposed planetary boundaries and safe operating space for anthropogenic activities. So this highlights the importance of looking beyond the scientific discovery. See, the reaction looks to be quite viable, economically viable also, but it is creating a lot of troubles like eutrophication. Therefore, it cannot be considered as a sustainable reaction. So now the time has come, the importance of looking beyond the scientific discovery and analyzing the global impact of chemistry using a systems approach. That is very important. These two examples, just giving a glimpse of the things, like how they both are green reactions, but at the same time, because of different reasons, they are not sustainable. Circular chemistry for sustainability. So this, particularly today's my talk, that one of my friend, Chris Slutvig, they are working on it from Netherlands, and I have just given the reference of that paper also, and they are working hard on it, Now the closed loop waste-free chemical industry. This approach aims to make chemical processes truly
meeting is being recorded. This meeting is being recorded.
That, instead of the microplastics. So that should be the option. So that is what the circular chemistry is trying to do, and that energy input is an investment. This is something very important because from early times we talk about the recycling, but recycling is consuming so much of energy, and so energy must be taken into consideration. So using waste as a resource can also contribute considerably to the energy efficiency of a chemical product over its entire life cycle. So in order to repurpose waste material into a feedstock, it is important to achieve a recirculation of molecules and materials that ensure an energy economy. For example, carbon dioxide can be converted into a variety of molecules like even alcohol or methane, and which can in turn be used for a variety of purposes. But the conversion of the process shouldn't necessitate more energy than that offered by the product offtake. Okay, this is very important. Conversion is fine, that CO2 can be converted into alcohol or methane or even amines, but the energy bookkeeping has to be taken care of. Yeah, that is there. This emphasis on the reusability of materials means that their longevity, which requires they remain chemically stable over many product cycle, is valued over their degradability. Because what the green chemistry says, that the product has to be degradable. Instead of the circular chemistry, if the plants, that it has to be more stable chemically, the product. Okay? Yeah. Because sometimes the degradation may not be very good. So by viewing the energy stored in the material as a long-term investment, circular chemistry aims to conserve energy and thus reduces additional energy inputs. Something that is very important. Controlled environment is another thing. The inherent reactivity of chemicals enables their conversion into value-added compounds, but can also lead to adverse effects. So in a similar manner to green chemistry, the circular chemistry strives to reduce the harmful impact of these compounds on the environment. Although the use of substances of concern may be unavoidable at some facilities, these should not be released to the environment. This is the thing, that even if suppose a very high toxic chemical is there, some material is there, so the effort has to be made that that should not be released to the environment. That is the CC6, that is circular chemistry principle 6, that it should not go into the public, it should not go to the society. This approach requires the continued conglomeration of industrial sites and enhanced cooperation between the companies. That is what is, these days the industrialization are done, that on one place there are a big industry, but there are cluster of, related industries are there, and if they combine in a manner so as to reduce the energy consumption, so as to reduce the requirement of the energy, just supporting each other. So that is where we can go to for the circular economy. That is one of the things. Product design. Optimal product design should target the most favorable end of life state, avoiding persistence in the environment and breakdown into harmful. This is another important thing. If suppose the product has to be designed in such a manner that just by getting, after the use, it gets degraded and creating harmful effect to the people around, to the society. Rather, it should be designed in a manner that it should not break like that. So biodegradable materials are often seen as sustainable. Yet the fact that the product will simply be disposed of in the environmental property, that is what earlier also I talked about, that the biodegradable materials are also sometimes they are problematic. Another issue often overlooked is that the microplastics I have just spoken about it. The polymers partially degraded from a plastic bottle causes more harm to the environment. That is. Following the green chemistry principles to encourage chemists to design materials for degradation does not unequivocally lead to an increase in sustainability. Therefore, rather than aiming for the product degradation, it is preferable to collect waste streams and instead convert them in dedicated plants that into value-added materials. So degradation should be preferred, should be avoided, and the waste should become a resource for any value-added product. Product stewardship. the circular economy relies on decoupling of material consumption and economic growth. This is something very important because we are into the time when the economic growth is very important. We cannot just go back. We cannot retreat from that, And but every time, we see that if we are consuming more material, so there will be more growth, but we have to have a balance on that. To promote this, the ownership of goods needs to be directed away from the user and back to the producer. Ownership of goods needs to be directed away from the user and back to the producer. This can be achieved by shifting payment model from ownership-based to service-based systems. And examples of this is the use of shared car. Yeah. One example, a very successful example of this approach is one in Egypt. ARB is a manufacturer of electrical appliances who resolved high cost in electrostatic powder coating by collaborating with the paint and coating supplier. One company, ExxonMobil. So instead of this ARAB buying the coating material per kilogram for their painting operations, the companies devised a process in which expenses were charged per square meter of metal material coated, and the powder waste was returned to the Nobel Company for recycling. So these kind of collaboration, and they saved a 20% reduction in coating use. So this is the service-based chemical industry is vital for circular chemistry. Service-based instead of the ownership. Okay, so now I will be finishing because Dr. Neha has asked me for some, running out of time maybe probably. The layer of circularity, let me go for it. So what the circularity says, first is reduction, reject, reduce, reuse, redistribute, repair, refurbish, repurpose, remanufacture, recycle, recover and return. We refer to 11 R's that provides a means by which to assess the end of the life option for the product. And this is how this is the letter of circularity. I think this is enough for today's and looking to the time constraint. So thank you very much. So I'm very much sure that circular chemistry will definitely be in practice very soon. A lot of work is being done on it.
This meeting is being recorded.
Any questions?
Any questions from
The circular
and
sustainability.
Anyway, no problem. You can take a question and can send it to me. No problem.
Okay, sir.
Okay, sir.
Okay, so
Thank you once again, Dr. Neha
questions.
Agrawal,
Neha.
the principal of the college. Thank you for giving me this opportunity to speak. Thank you so much.
So,
there is a query principal wants to know
what is green? How to conduct
green audit.
Yes. How to go about it?
No, earlier there was an environmental chemistry where we are making all kinds of waste. We were never thinking of avoiding the waste. And once all kinds of waste were made, like air was polluted, water was polluted, and then there were methods of remediation of those kind of remediation of the waste air, remediation of waste water. But once the green chemistry has come to the 12 principles, almost in 1985, so we have to avoid waste. Yeah, we have to avoid waste. We have to there are 12 principles of that. So green audit is that you are not adding any carbon dioxide to your immediate environment, because of course carbon dioxide is very much there. There was a time before the industrial revolution, whatever carbon dioxide coming out of the humans and the animals, that was being utilized by plants, so there was a perfect cycle. But now with the industrialization, excess of carbon dioxide is coming. Whenever we talk of carbon, that is carbon dioxide. So any of the activity, any of the action within the campus should not add any extra carbon. I mean, that is what you have to look around. Even smaller thing like, in the college, like whether the light, sometimes, there is a habit of the children, just to switch off the lights, not to use the light when you are not in the room. That is, you are just contributing to the planet, But if suppose somebody says, that the energy, that the light, electricity was a green electricity. So what is the harm in using the excess electricity? Because see, if the electricity is generated by coal or oil or petrol, that is not good. But if suppose, you are just using water for that matter, it's a green electricity. So you can use as much electricity as possible. Anyway, thank you.
What I gather from this course is that restoration and rehabilitation mechanisms must be used more and more. We should have closed-end loops, and there should be innovative chemistry, because for sustainability we need innovations, and our innovation should be sustainable too. So to reduce environmental stress, it is suggested that there should be reuse and reuse of material. Thank you so much, sir. Now I would like to call upon Neha family for thank you, and then we will disperse for just 15 minutes, strictly 15 minutes tea disperse for tea break, and come back again for the next session. Thank you all.
I didn't even realize you're going to give a talk.
No, but I do anyway. So you missed again this time. And but Dr. Neha managed you to bring you to Lucknow, at least on air.
My good friend Amrit, I meet him all the time at the International Chemistry Olympiad.
I'm also a good friend, man.
Now you're my best friend. I mean, wow.
Okay.
Really great to see you. And we must chat because I'm doing quite a lot of work on APGs and with circular green chemistry. Yeah, I've got some interesting work that I can work with.
Really?
Yeah.
We will.
So when you come to Durban, when you visiting up
So
in
when you
Durban?
are coming to China and when you are coming to India, man?
Well, if the consulate gives me a visa to the trip.
That was really tough. It was very tough. So anyway, Dr. Neha is waiting, like going for tea and all. So Ajay, we'll talk in the evening.
Okay, see you, bro. Take care.
Thank you, sir. Thank you, Ajay, sir. Thank you, Ajay, sir.
Thank you so much.
The former Board of Science on behalf of the college and the organizing committee of this wonderful conference. First, I would like to express my deepest gratitude to Dr. Anirudh Balakrishna Patil for his outstanding presentation on the structural re-engineering of mesocomposite materials for sensor applications. Your innovative and insights into material science and sensor technology have truly captivated us and broadened our understanding, sir. I would like to extend my heartfelt gratitude to Mr. Ajay Visweshwar for his valuable talk on rejuvenation of cellulose-based insulating paper used in high-voltage power transformers. Your presentation was both insightful and impactful, sir. Your research on improving critical materials for electrical infrastructure has opened up essential avenues for innovation in this field. A special thanks to Professor Brijesh Parekh for sharing his expertise on sustainability through circular chemistry. Your emphasis on circular chemistry as a pathway to sustainability resonates deeply with all of us, inspiring us to think about environment in new and impactful ways. I would also like to express my sincere thanks to the principal, Professor Majla Upadhyaya, for her leadership and unwavering support in making this event a success, and our deepest appreciation go to the convener and co-conveners for their hard work and dedication in organizing this international conference. A very special thanks to Dr. Anurima Banerjee ma'am for her excellent coordination of this session and for ensuring everything ran smoothly. Finally, I would like to thank all our delegates, both offline and online, for their participation and insightful questions and making this session truly interactive and meaningful. Thank you once again to everyone involved, and I humbly request all of you to have a tea break and breakfast. Thank you.
I just have one more announcement. We will resume the session after 15 minutes, after tea break. Thank you.
Properly the electronics, then it will deliver the different compound. So in this way we are able to access a lot of different frameworks, and we are able to develop different kind of libraries. And now how we can improve the selectivity and efficiency. And so if you will consider a reaction and if you are not optimizing the reaction condition, then the possibility is this one, that if you will take the compound and there is no mechanistic understanding, then you will have different kind of products and which are be useless. And when you have mechanistic understanding, then you will lead to desired compound. So that's the importance of the mechanistic understanding of the complex scaffold. And then you have predictable product distribution. And also you will reduce the side order, and you will have the best reaction path to get the best compound. So in this reaction, you see the reaction is going just at the room temperature and utilizing a polar solvent, for example, nitromethane. If you are going to take the polar solvent, then it triggers to the different pathway and you will get the different compound. That might lead to the re-aromatization of this compound, and so that will follow the different path. And so here we have like rapid scaffold diversification from one path which we have studied, and we are able to get a lot of compounds, and with the mechanistic pathway we are able to branch the pathways, and we are able to develop different kind of compounds. And these platform strategies are allowing us to develop medicinal chemistry program, and we are accelerating the lead optimization in this way. And so we have developed a lot of compounds, developing the mechanistic pathways, and we are optimizing and screening the compounds for human for developing antimicrobial compounds. So then we could fight against the antimicrobial resistant species. And in this program, we are screening, we are taking human intestinal cells and then we are incubating them, extracting RNA and doing RT-qPCR and another biological assays to get the lead compounds. So in conclusion, we have developed a mechanistic pathway enabling rational synthetic design, and we are able to predict and expand the medicinal chemistry toolbox and mechanism-driven synthesis concept, and the theory is quite new, and we are trying to integrate it with the mechanism, biological mechanism of drugs, so that we can in future we could be able to design some synthetic pathways for particular disease. And this program is with the EU funded project, and that's called Maximum. Maximum itself means to maximize the immunity. And here you can see in the picture, this is the first Maximum General Assembly meeting that was in Bonn, France. And in this research program, there are 5 institutes and a couple of industry partners are involved. And I'm working at Helmholtz Center of Infection Research, as you can see here. And this is the Helmholtz Center, Braunschweig, and our department is located in the CBio building, which is this one. And now I would like to thank you, and again, if you have questions, I would be able to answer.
And I would request Professor Abhinanda sir and Professor Ramkumar sir to please come up on the dais. Dr. Srivastava served as an assistant professor of chemistry at a reputed engineering college in the Delhi NCR region, affiliated with Dr. APJ Abdul Kalam Technical University, Lucknow, India. He earned his master's and doctoral degrees in chemistry from Chaudhry Charan Singh University, Meerut. His research interests encompass coordination chemistry, medicinal chemistry, green chemistry and bioorganic chemistry. Dr. Srivastava is actively engaged in supervising PhD scholars in these areas of specialization. He has authored numerous research papers, edited and authored books for postgraduate students, and contributed book chapters with reputed national and international publishers. Dr. Srivastava remains deeply committed to academia and research, contributing consistently through peer review of scholarly articles, delivery of invited lectures, and presentation of research papers at national and international conferences, seminars, webinars, and workshops. What an illustrious biodata of sir. So I would now ask sir to kindly proceed with the flash talk.
can come about here.
Present topic, coordination compounds as an operative tool in medicine. And we are all aware that the medicinal chemistry has been reduced by the organic molecules, but as the demand of the medicinal moieties are going to increase due to several lifestyle diseases and resistance towards the ongoing molecules. So, in the search of the novel moieties which have the potential to behave like the medicine, is obvious the need of the medical field. So, organic molecules were going to be embedded with metal complex, metal salts. Then the new class of the compound, coordination compounds are produced which have the potential to behave like the medicinal molecule. So, here, this is just to a phrase that the copper anon of Indonesia figure star, which was a Latin prop given by the father of chemotherapy, called ANRF, according to which a molecule only can behave like the drug when it binds. So the binding must be with the biological components inside the shells of the living being.
झुके
So the third chemotherapy was coined by Paul Enrich, and which is basically have the focus on the molecules. They can bind on the molecule. Those molecules which can bind, only they can act as the drug. So he was awarded Nobel Prize, and the chemistry to the pharmaceutical agents is termed as the pharmaceutical chemistry. The word medicine, pharmaceutical, and drugs are often used interchangeably. So, human beings have been using drugs to treat illness and diseases for more than 3,000 years. So, this is again the man named Oswald Silver, and generally recognized as the founder of the modern pharmacology. So, in 1872, he became professor of the pharmacology at the University of Strasbourg in Austria, where he studied the pharmacology of chloroform and chlorohydrate, and in 1878 published the classical text outline of the pharmacology. Since the study of his work and focusing on the chemicals as the pharmaceuticals, the era of the modern pharmacy has been started. So this is a graph or chart transition towards the different era, where the first era and the golden age has been represented in the yellow color, and the next the dark age and the new era. In the new era of the medicinal development, from the 1960 to 2019, we have a group span of the related to the antimicrobial peptides development, and there are so many developments have been achieved in these development decades. So, why the need of the coordination compound as the drug molecule? Though many medicinal molecules are available in hands of the medical practitioners, but resistance towards the clinical drugs and elevation in the lifestyle disease creates continuous research demand in the discovery of more effective and safer drugs. Here, to release the medicinal gas, metal complexes have been proven a best tool to cure many microbial infections and metabolic anomalies in human body. Some researchers in the field of the bioactive coordination compound designing produce clinically approved metal complexes based drugs for treatment and cure of many lethal diseases like cancer, rheumatoid, fungal infections, bacterial infections, neurodegenerative diseases, etc. So here so why the new type of the medicines are required? Because if we are just going to focus on antimicrobial resistance, then according to a report, up to the year of the 2050, we are going to be highly burdened by the antimicrobial resistance. There are 28 million people projected to be fall into poverty because of the antimicrobial resistance. 7.5% decline in the global livestock production. There are 3.8% decline in the global exports. Up to $1 trillion US global increase in healthcare costs. So this is just one factor, the antimicrobial resistance, which is going to influence our economy by such a great influence up to the year of the 2045. Then other factors which are related to failure of the ongoing drug or the decline in the efficiency of the ongoing drugs definitely going to suppress our economical growth and other factors for the requirement of the development. So this is the time to search new type of the medicines, new zone of the medicinal values. So here most of the bacterial organisms outline the number of the epidemic outlines and notable bacterial infections and fungal infections. There are so many list of the bacteria and fungi which are very dangerous to the human being and causing numerous deaths, number of deaths annually at the global level. Here is the list of the bacteria developing different types of the diseases. Like the same way, fungal strains are also very dangerous for the human being, and they are just going to be resistant due to the different types of the factors, misuse of the antibiotics, so or the change in their DNA also. So here, one of the very horrible data, percentage increase in various types of the cancer cases up to the year of 2045 worldwide. Figure A is shown in the human male and the B for the human female. Here we are going to see the 73.1% colon cancer may be increased up to the year of the 2045 as per the report, and the females there is the increase of the 82.1% pancreas cancer. This is the probable data of increasement of such type of the cancer disease. So where till the date we don't have the such type of the medication which can cure and control the cancer properly, and meanwhile the drugs are going to be resistant day by day. So this is the time to innovate and design new kind of the drugs molecules to protect and fight against these pandemics in the cancers and other diseases. So this is a very horrible data. Other type of the cancers are also being like stomach cancer plus 72%. So here, estimated rate of the mortality caused by the different cancers in the 2022. Up to the year of 2022, the rate of death due to the cancer is very high due to the breast cancer, that is the 49%. जब जितना death हुआ है उसमें 49% death तो breast cancer की वजह से हुआ है. 25.6% cervical cancer की वजह से, 19.6% colon cancer की वजह से और 5.8% due to the kidney cancers. So it is also a warning for especially for the females. They must be aware and conscious about their health related to the cancer symptoms. Here now. That's why I am saying the metal-based platform to be applied as a drug molecule. not only the coordination complexes but other molecules in the form of the photoactivated framework, small metal complexes, inorganic, organic hybrid materials, metal modified macromolecules, metal oxide nanoparticles. There are so many options provided by the metal related medicines. So here I am specifically going to discuss with the metal complexes. Coordination chemistry as well. In which fields can be applied? The antibacterial, anti-cancer, antifungal, antioxidant, anti-inflammatory, antibiotic, antidepressive, and each and every type of the Alzheimer-like neurodegenerative diseases can also be tested for the effectiveness of the metal complexes. So, metal complexes have the possibility due to their biological importance, biological compatibility with human cells. अब ये बात आती है क्यों कोऑर्डिनेशन कंपाउंड्स क्यों हो सकते हैं? इतने सारे मॉलिक्यूल्स के ऑर्गेनिक मॉलिक्यूल्स में होते हुए कोऑर्डिनेशन कंपाउंड्स किस तरीके से इतने बड़े-बड़े मॉलिक्यूल्स हैं? मोस्टली जो आपके ऑर्गेनिक मॉलिक्यूल्स हैं वो स्मॉल साइज के होते हैं, दे आर वेरी इजी टू फिट विद द बायोलॉजिकल सिस्टम. व्हाई? We people are very curious. Why? क्यों coordination chemistry can be accepted as a medicinal tool? Because nature is also asking. Our nature is also asking, where are you coordination chemistry? Where are you coordination chemistry? Where are you coordination chemistry? Then the coordination chemistry exists in the nature. Here, the nature is replying, I am in your chloroplast here, because if a large molecule like the chlorophyll may exist inside a living cell of plant, then it is the proof that metal complex moiety can be adjusted inside the living cell. Another one. This is the structure of the chlorophyll. Here, the human being is also plant. पूछ रहा है तो human being क्यों नहीं पूछेगा? मेरे अंदर कहाँ हो तुम? Where are you? Where are you? Where are you coordination chemistry? Yes, I am in your blood. Yes, I am in your blood. Throughout your life, I am running. A big molecule of the hemoglobin is continuously running inside our cells to carry oxygen from each cell of the body. Then, this is the proof of existence and adaptability of the metal complexes like large molecules inside our body. When natural existence is proved, then its compatibility as a medicinal tool can also be recognized. So, this is the vitamin B12 cobalt complex. Here, why? How can metal complex can be accumulated or act as a medicine inside the body cell? Because metal attacks can bind DNA, can bind with the DSA binding and docking properties, DNA cleavage, cytotoxicity, higher binding affinity, higher binding energy, higher anti-cancer activity. These are the few factors which make metal complexes reliable and compatible to be fit as a drug molecule inside the living cell. So, why? हम लोग बाजार में जाते हैं, पैरासीटामोल, एस्प्रिन, कोई भी एमोक्सिसिलिन, different kinds of drugs आप देखते हैं, मेटल्स देखते हैं आप, मेडिसिन देखते हैं आप, उसमें आपको सिर्फ और सिर्फ ऑर्गेनिक केमिस्ट्री नजर आती है. लेकिन कभी हम लोगों ने ध्यान नहीं दिया इस चीज पर कि we are already surrounded with very important medicines, commercial medicines, which are available on the medical shops and used in abundance by our doctors to treat many lethal diseases. Cisplatin is one of the major anti-cancer medicine which is used to treat the different types of the cancer. This is available in market. Paraplatin is another compound of the plating which is used in market and used for the treatment of the cancer. This is a type of plating. Oxaliplatin, this is another platinum compound which can be used, which is being used for the treatment of the cancer. This is the Redura brand name, the complex of the gold, and it is used for the rheumatoid arthritis. अगर किसी के घर में कोई लोग आर्थराइटिस से पीड़ित होंगे तो शायद उनके घर में ये डिब्बी मिल जाएगी. So these are the metal complex, yeah, metal based medicine. This is the bacteriacin gene brand name. This is the compound antibiotic bacteriacin, the gene complex already available in market. Similex is the metallic component. This is used widely. Zero form. This is the complex of bismuth. And so many more compounds are available in our market based on the metal, moieties, and they are very effective as the organic medicines. So here, not going so much fast, the modern synthesis type of anti-cancer coordination compounds can be discussed here in very brief. As we are talking about the sustainable development, so being the coordination chemist, it is our responsibility to find out, to search such paths to develop and design coordination moieties which have the drug potential by the sustainable means the green chemistry. All the green chemistry principles can be easily applied on the synthesis procedure of traditional method of coordination complex synthesis. We have the natural synthesis method, ultrasonic synthesis method, aqueous solvent synthesis method, mechanical synthesis method, and some other green methods which can be applied very beautifully and effectively, and the resultant in the form of the yield and the reduction in the time has been reported by various scientists, various researchers to design these bioactive compounds. I am just going to represent here. These are the some organic, metal-based component, platinum and non-platinum component, which are already in market or under clinical trial or have passed different phase of the clinical trial to be treated, to be used for the anti-cancer medicine. Here, as I have discussed, the material chemists are also trying to minimize the side effects on the environment by the synthesis procedure. That's why coordination chemists also adopting the green chemistry aspect for the synthesis of the material. Especially, I am coming here to discuss the anti-cancer molecule. So, this is the some notable compound which are very beautifully synthesized by the different kinds of the green aspect methods and beautifully designed to produce good yield and time efficient molecules having the anti-cancer property. Like this molecule, this ligand will be synthesized by the microwave synthesis, and this ligand is synthesized by the ultrasonic synthesis, mechanical synthesis, and synthesis in the aqueous solid. And further, these ligands were applied to develop different kinds of the metal complexes which have the potential to inhibit the cancer cells. These are some notable compounds that are reported earlier with the high capacity to inhibit the cancer cells. Different kinds of the cancer cells have been checked to treat or to inhibit the cancer cell growth or by different types of the bacteria. This, as people are saying that the platinum complexes are the major components which are used as anti-cancer drugs. So, coordination chemists are trying to put some new molecules which are the non-platinous molecules developed with the uranium or the zinc or the copper, and many more have the good efficiency to inhibit the cancer cells. These are also some examples. Mostly, we have the nitrogen occupied and oxygen occupied ligands which can produce good quality of the anti-cancer molecules. Here, some other examples are also produced the cobalt molecules, cobalt complexes, and here cobalt nickel and the zinc and cadmium molecules which have the efficient anti-cancer property developed by the green root of the synthesis. Okay. Here are some of examples. There are some recent examples. So here the stack bar graph representing the cell percentage cell viability of the complexes against various cancer cells. Those complexes we have discussed here, and some of were tested for the percentage cell viability, and they give a very good result for the MCF level and the STT at the HK293 cell lines. So here we can say that the metal complexes may be a promising tool to treat the cancer in upcoming future. Targeted cancer cell lines by metal complexes have gained credence as many of them are being used to treat these cancer disease. Drug molecule target the cancer cell line in many ways which are well known with DNA interaction, oxidative stress reduction, immune response activation. The DNA interaction of metal complexes coordinated with the nitrogen ligands and some other heteronucleosides occurs by the various modes of the bonding, hydrogen bonding, electrostatic and hydrophobic groups. The significance of nitrogen coordinating sites is misbehaves as in the interaction with the DNA and the metal ions combined with nitrogen sites of the nucleobases. So the metal complexes can induce reactive oxidation species and can induce apoptosis by knowing the nature of the cell. Process can be further processed directly in the cancer cell. The metal complex nature of the nitrogen ligand provides the correct pathway to get rid of cancer with a highly efficient matrix. The non-prenatal metal complexes provide some advantages in mechanistic properties of the anti-cancer drug delivery system, such as the higher action to therapeutic potency, off-target toxicity reduced if will not affect healthy cells in the human body. Okay. The significant property of the some complexes can be attributed to the smooth oxidative damage of the tissue by metal by a free radical trajectory which is analogous to the pentylation. Binding ability to DNA is observed to modified and metal centers are altered with a different metal ion. On the basis of the research done by the oncologist and chemist on anti-cancer activity of potential compound, the probable mechanism of anti-cancer activity of complexes may be approached in the figure on the next slide. So the general representation of the mechanism when drug molecule containing the metal ions entering the cancer cells, binding to the DNA or protein and it damages it and DNA damage oxidative stress, apoptosis pathway and the cancer cell. This is the general mechanism which is very easy to understand by our UG and PG students for their investigations, but the detailed mechanism is not so easy. But different aspect of the metal complex can be affect or can achieve the different pathways to so the cell growth to inhibit the cell growth. So here I acknowledge the members of this fantastic conference and also the authorities of the university for providing research facilities. So I think I have the time to be finished. So I just want to show the some achievements from the my laboratory. This is my undergraduate students are working there and they are trying to develop some green route of the drug for preparation of the drug molecules like the aspirin and paracetamol etc. At the level. Participation from our research group in the complex emission. Sometimes the complexes have been derived and they are under investigation for their anti-cancer activities. Here are some data. In the bioactivity, there are docking studies. I am not going to discuss all these things because the time is so much limited and not just to interpret the topic as to the flash top only. These are the molecules developed from the my laboratory and they have some specific structure and these molecules are under specific investigation for the structure and biological potential. These are some of the notable publications from my laboratory. We are publication house from time to time. Here are some bioactive compounds. Here are some one of the projects in my laboratory with my PhD and PhD students. These are the publication. This publication was done by my PG students last year, and one of the recent publication in 2026, my PG students is got publication in the chemistry communication. Research advancement in the clean synthesis of the cancer formulation. There is the nitrogen oxide organic molecules. This is my research team, my PhD students and the UG students and PG students. Thank you. Thank you.
Thank you very much, sir. That was a very illustrious presentation, and the students of chemistry present over here must be learning how to present the topic which they have chosen, as well as how to go about in the research. And sir has given them an enriched presentation, a great learning, sir. Thank you very much.
As well as India. Now the scientists are unable to invent a proper medicine to take care of the disease. So Russia recently developed one medicine that is based on the mRNA, and it is proposed with the therapy as well as providing a consistent medicine to the patient. So why the India is unable to fulfill the requirement of to just create a new medicine for the cancer? What is the reason?
इसकी कैसे ही है। अगर आप द साइड हम बताएं तो जब बच्चों को हमारे साइंस पढ़ना होता है, चाहे वो किसी कोचिंग सेंटर में जाके एसएससी की तैयारी कर रहे होते हैं एट द लेवल ऑफ द ग्रेजुएशन, ठीक है, एंड आफ्टर पीजी दे गेट इन्वॉल्व जस्ट टू गेट क्रैक द गेट एग्जामिनेशन. दे आर नॉट लर्निंग द साइंस, व्हाट इज द कांसेप्ट बिहाइंड द साइंस. दे आर जस्ट ट्राइंग टू पुट देयरसेल्फ इन अ जॉब. दैट्स व्हाई वी आर हियर at this stage. But I am proudly saying that during the COVID season, it was India who developed a great, fantastic vaccine to serve the globe from the setting community of the globe. So India में potentially कमी नहीं है, और कुछ हमारे पास innovations, ideas बहुत सारे हैं, लेकिन उसका implementation बहुत सारे factors की वजह से नहीं हो पाता है. अगर आप लोग और हम लोग एक साथ एक प्लेटफॉर्म पर आएंगे, definitely we can make a new India. Thank you so much.
Thank you so much, sir. Our next speaker is Professor Ramkumar Tiwari, and Professor Ramkumar Tiwari kindly.
किसी को हिंदी में समझने में दिक्कत तो नहीं होगी?
बहुत ही अच्छा होगा।
अगर हिंदी में समझने में दिक्कत ना हो तो हिंदी में बोले ना, बहुत
अच्छा रहेगा। बहुत अच्छा रहेगा।
थैंक यू वेरी मच। काफी समय से हम लोग बैठे हैं, सब सुन रहे हैं, तो कई बार कॉन्फ्रेंस में थोड़ा सा बोझिलता आ जाती है। अभी एक मैम मिली थी, बता रही थी उनको हिस्ट्री वाले हैं, तो मैं भी फिजिक्स वाला और केमिस्ट्री से बचपन से करता रहा, केमिस्ट्री से छोड़ दी, लेकिन जब रिसर्च का समय आया तो कहते थे कि एकम सत्य विपरा बहुधा वदन्ति, सत्य एक ही है, अलग अलग तरीके से लोग सोचते हैं उसको। तो जिस केमिस्ट्री से डर के भागा वही केमिस्ट्री के पीछे पड़ गई, और वही पॉलीमर, स्ट्रक्चर, केमिकल प्रॉपर्टीज सब समझना पड़ा। और ऐसे भी लाइफ की केमिस्ट्री समझना बहुत जरूरी होता है, बिना केमिस्ट्री काम चलता नहीं है। तो सबसे पहले तो आप सब बैठ के सुन रहे हैं और सबका उत्साह बढ़ा रहे हैं बोलने वाले का, बहुत बहुत धन्यवाद आपको। आपने हम सबका उत्साह बढ़ाया है और हम लोग हिम्मत कर पा रहे हैं कि बोल पाए आपके सामने। और अब इसके पहले कि हम इस विषय पे आए, मैं चाहूंगा कि केमिस्ट्री का जो सेमिनार है और वो भी इंटरनेशनल लेवल का है, तो एक छोटा सा खेल केमिस्ट्री में खेलेंगे और उसके बाद फिर मैं अपनी बात को शुरू करता हूँ। केमिस्ट्री के 3 शब्द हम लोग बहुत कॉमनली जानते हैं, फिजिक्स में भी है, इसलिए फिजिक्स वालों की तरफ मैं बोल रहा हूँ। जो फंडामेंटल पार्टिकल है इलेक्ट्रॉन, प्रोटॉन और न्यूट्रॉन, सब जानते हैं, सबको पता है। तो ऐसा करते हैं कि एक खेल खेलते हैं। हाँ, मैं आपके मोबाइल है, मैं देख रहा हूँ सब लोग मोबाइल में एंगेज हैं, थोड़ी देर मोबाइल को छोड़ देने तो अच्छा लगेगा। हाँ, खाली कर लीजिए। 3 शब्द मैं बोलूंगा, इलेक्ट्रॉन, प्रोटॉन, न्यूट्रॉन। खेल खेलना है बैठे बैठे, अच्छा लगे तो अपने घर में भी जाके खेलिएगा बाल बच्चों के साथ, अपने घर में। करना क्या है, मैं बोलूंगा इलेक्ट्रॉन तो ऐसे करना है, प्रोटॉन कहेंगे तो ऐसे करना है, और न्यूट्रॉन को ऊपर करना है। कर लेंगे ना? कोई दिक्कत तो किसी को नहीं आएगी इसमें, बस यही खेल। याद रखिएगा, जो गलत खेलेगा वो क्या हो जाएगा? आउट नहीं होना है। जो गलत खेलेगा वो सीधे सीधे कहना चाहिए लगता है कि मरेगा। क्यों मरेगा ये भी बता दें। हमारे भारतीय संस्कारों में जो हमारे भारतीय खेल हैं उसमें हम आउट नहीं होते हैं। आप कोई भारत का खेल बताइए। कबड्डी, कबड्डी है ना? कबड्डी में आउट होते हैं कि मर जाते हैं? मर जाते हैं। और फिर दूसरी तरफ वाला कोई मर जाता है तो जिंदा भी हो जाता है। ये भारत है, ये भारत का ज्ञान है। तो हमारे यहाँ जीना और मरना भी खेल खेल में होता है ना? हम ये नहीं कि इस बार आए तो आखिरी बार है, अरे फिर आएंगे, फिर जाएंगे, फिर आएंगे। ये हम लोगों का हमारे भारत ने हमको सिखाया है। और भारत का मतलब ही होता है भाव मतलब ज्ञान, व्रत का मतलब लगा हुआ। तो लगातार ज्ञान में लगा हुआ है, ज्ञान की खोज में लगा हुआ है, वही भारत है। आज भी आप ज्ञान की खोज में लगे हुए हैं। तो हम लोग इसको खेलते हैं। पहले मैडम तो आपको टाइम बता दीजिएगा कितने मिनट मुझे खत्म कर देना है, तो उस हिसाब से काम करना है। ठीक है, तो फिर जल्दी जल्दी हुआ करें। चलिए, सब लोग रेडी होंगे? क्या करना है? इलेक्ट्रॉन, प्रोटॉन, न्यूट्रॉन। हाँ, खाली होगा तभी खेल पाएंगे। इलेक्ट्रॉन क्या करना है? ऐसे करने का। प्रोटॉन का सभी लोग खेलेंगे और न्यूट्रॉन पे हाथ ऊपर जाएगा। इलेक्ट्रॉन, प्रोटॉन, न्यूट्रॉन, इलेक्ट्रॉन, इलेक्ट्रॉन, प्रोटॉन, न्यूट्रॉन, न्यूट्रॉन। देखिए आप आप लोग अपने घर में खेल सकते हैं इसको। माता पिता के साथ अपने बाबू के साथ। अब आइए हम लोग चलते हैं इस विषय पे। जिस विषय को आपने चुना है बहुत ही जरूरी विषय है। दुनिया में हम आए हैं तो सब कुछ खा पी के खत्म करके यहीं चले जाएं तो आने वाली पीढ़ियां क्या देखेंगी? खाओ पियो मौज करो, आने वाले लोगों को देखेंगे। ऐसा नहीं करना है। तो आपने विषय ये अपना चुना है सस्टेनेबल डेवलपमेंट का, सस्टेनेबल फ्यूचर का। ऐसा फ्यूचर होना चाहिए जो सतत विकास में रहे, सतत रहे। हमारे बाद भी दुनिया रहे कि नहीं रहे? तो वो दुनिया बनी रहे तभी रहेगी ना जब हम कुछ छोड़ के जाएंगे उनके लिए। तो अपने जो आवश्यकता की चीजें लेना, बाकी छोड़ जाना, यही सस्टेनेबिलिटी है। अब इसमें केमिस्ट्री का जो रोल है वो क्या हो सकता है और कैसे केमिस्ट्री इसको दूसरे डिसिप्लिन को जोड़ेगी, ये आज का विषय है जो आपने अपने टॉपिक में लिया है। और मैं भी इसी के इर्द-गिर्द रहने की कोशिश करूंगा। हमने भी इसमें कहा है कि द साइंटिफिक क्वेस्ट फॉर इको फ्रेंडली कल्चर में, देखिए हम अपने अतीत से अपने को काट नहीं सकते, अच्छा बुरा। और भारत में तो सब कुछ अच्छा है, कुछ बुरा ही नहीं। हम लोगों ने बहुत अनुभवी मैडम हमारे सामने बैठी हुई हैं, सुधा मैडम। हम तो केमिस्ट्री बताया बिल्कुल नहीं समझते हैं, मैडम को तो समझ में सब आता है। अरे आप बहुत अच्छा बता नहीं तो अब हमको गाइड कीजिएगा कि हमें करना क्या है। इसलिए मैंने आपसे कहा था कि हम जब बोलेंगे तो उसके बाद आप भी सब परीक्षण करवाएंगे और आप भी सब मार्गदर्शन लेंगे। तो मैडम इसमें हमारे कल्चर में है वो चीजें सतत हम अपने साथ लेके चल रहे हैं। मैं फिजिक्स का बंदा हूं, लेकिन हुआ क्या कि एक्सीडेंटली जो केमिस्ट्री आती नहीं थी, फिजिक्स में आ गए, कुछ मिला जुला करना था। तो कुछ विषय बचपन में सोचते थे कि कुछ रिसर्च करेंगे, तो सही बना मैडम ये समझ में आता था रिसर्च क्या करेंगे। जिसमें दिमाग जाए चला वही लोग खोज चुके हैं, वही कर चुके हैं। कभी सोचा पंखा बनाएंगे, पंखा बन गया, बल्ब बनाएंगे, बल्ब बन गया, टेलीविजन बनाएंगे, अरे कुछ जो सोचो वही बन गया। तो हम सोचते थे हम करेंगे क्या, हमारे कुछ बचा नहीं है। और जब रिसर्च किया तो उसमें टॉपिक मिला हमको, कैसे होगा मैडम, अरे इधर प्लीज आइए। तो जो टॉपिक मिला वो था हमारा नॉन लीनियर ऑप्टिक्स का। अभी ऑप्टिक्स को आपको सुने हैं, अब नॉन लीनियर परमाणु क्या चीज होती है हमको ही समझ में नहीं आया, रिजल्ट पूरा हो गया। तो हमको लगा कि अब ऐसे विषय में आना पड़ेगा जो हमको भी समझ में आए और दुनिया को भी समझ में आए, ताकि हम बता भी सके कि हमने किया है। तो मैडम इत्तेफाक से हम अपने आसपास के वातावरण जब देखे, अपने घरों में देखे, तो हमको कुछ परंपराएं देखी जो बेहतरीन परंपराएं थी। हमको अपने माइंड को, सोल को कंसंट्रेट करने के लिए हमने ईश्वर की कल्पना की है, परिकल्पना की है, और हम अपने आसपास के वातावरण में देखते हैं, हम लोग पूजा पाठ करते हैं और तमाम प्रकार की मूर्तियां होती हैं, तो उनको लोग डिस्पोज ऑफ करते हैं। आप चित्र देख रहे होंगे, इसमें साफ साफ दिख रहा है। ये जो राइट साइड वाला चित्र है, किसको अच्छा लग रहा होगा? किसी को अच्छा नहीं लग रहा होगा, हमें भी अच्छा नहीं लगा। तो हमने सोचा कि ये अच्छा नहीं लग रहा है, तो यही वो दर्द हो रहा है, यहाँ से यहीं से रिसर्च हो सकता है। मैंने वहीं रिसर्च को शुरुआत कर दिया कि चलो ऐसा करते हैं, ऐसा करते हैं कि जो समस्या है इसका कोई समाधान हो जाए। तो समाधान क्या होगा, इसमें हम लोगों ने एक विषय लिया। एक हर किसी के अंदर पॉजिटिविटी है, अच्छाई है, लोग चाहते हैं कि सब अच्छा हो, परंतु अच्छा कैसे हो? कहते हैं कि ईश्वर भी वहीं आता है जब स्वच्छता होती है। आप वो पूजा पाठ कीजिए, गंदगी फैला दीजिए, भगवान को आना भी होगा तो कहीं यहाँ तो गंदगी है, कहाँ चलो उधर चले चलो। लखनऊ में देखे भंडारों के शहर है, खूब भंडारे लगते हैं, और भंडारे के पहले हनुमान जी लोग पूजा भी कर लेते हैं। अब कहते हैं कि 20 साल से भंडारा लगा अभी तक कृपा अटकी हुई है मेरे पे। आपके कॉलेज में भी होता है। अब कृपा क्यों अटकी हुई है भाई? अरे हनुमान जी आपके तरफ आ रहे थे, अब देखे कि वहां गंदगी का अंबार आपने लगा दिया था, तो कहे चलो उस तरफ जहां साफ सफाई हो, चले गए वहां पे, कृपा आप तक आते तो रुक गए। तो स्वच्छता पवित्रता हमारे जीवन का पार्ट है, हमने परंपरा से सीखा है। और बड़े मंगल जिसको हम लोग खूब देखते हैं कैसी स्थिति होती है, तो मुझे वहां ध्यान आया कि हमको केमिस्ट्री के लोग थोड़ा हेल्प कर सकते हैं। क्योंकि अभी सर बता रहे थे, इसके पहले हमने ट्रिपल आर सुना था, 5 आर सुना था, वो 11 आर की चर्चा करके गए हैं। और अभी ग्रीन केमिस्ट्री की चर्चा हो रही थी, तो हमको लगा केमिस्ट्री के लोग इसमें हेल्प करेंगे। और ये देखिए कैसे ये भी समझ में आया। हुआ क्या कि मैं लगातार लोगों से बात करते रहता हूँ कि ऐसा कुछ किया जाए कि ऐसी मूर्तियां बने कि अपने घर के गमले में उसको गला दिया जाए। तो लोगों ने कहा है कोई दिक्कत नहीं, पानी में डालिए, बाल्टी रखिए, उसमें गल जाएगा। लेकिन जब हमने देखा कि हम तो अपने बाल्टी में मूर्ति को डाल के 2 महीना 4 महीना छोड़ दिए, गली नहीं, तो क्यों नहीं गलती भाई? क्यों नहीं गलती है वो? क्योंकि वो प्योरिटी होती है। अब प्लास्टर ऑफ पेरिस जैसी चीज जो गलने वाली नहीं है, बहुत सालों के बाद गल भी जाती है तो चिपचिपा हो जाती है, जिस पानी में जाता है वहां पर वहां के ऑक्सीजन को नष्ट कर देता है, कैसे काम चलेगा? अब क्या इसके लिए कहा जाए कि आप अपने परंपराओं को छोड़ दें? नहीं, साइंस के पास ये विकल्प है। साइंस हमको ये साहस देता है कि अगर समस्या है तो समाधान है, और हम उस समाधान के पार्ट बने। यही जो है हमारा कर्तव्य है। हम अपने टेम्परामेंट को, अपने ज्ञान को, अपनी परंपराओं को जोड़े आपस में और एक समाधान प्रस्तुत करें। यही विज्ञान का उसी तरफ को चलना है। थोड़ा आगे देखिए, अपने यहाँ हम लोग बहुत बात करते हैं IKS की, जो हमारा प्राचीन ज्ञान विज्ञान है, उसकी हम बात करते हैं। तो उसमें सब कुछ दिया हुआ है, यहाँ कुछ भी खोजना नहीं है, इसीलिए इसको सर्च नहीं, रिसर्च कहते हैं। हमको जो हो चुका है उसी को रिसर्च करना है, दोबारा सर्च करना है। अगर कुछ बना देंगे तब तो वो इन्वेंशन हो जाएगा, वो नई चीज हो जाएगी। जैसे टेलीविजन नहीं था, टेलीविजन आ गया, वो इन्वेंशन हो गया, इंटरनेट इन्वेंट हुआ, बट हम तो रिसर्च करने वाले हैं, हमें दोबारा सर्च करना है। अब क्या क्या है देखिए, हमारे यहाँ हमारे ज्ञान विज्ञान में परंपराओं में मिट्टी के बारे में चर्चा हुई है, सॉइल के बारे में, ऐसे बाइंडर्स के बारे में चर्चा हुई है जो कि मजबूती देते हैं, केमिस्ट्री का जो मिट्टी है उसको देते हैं। ऐसे कलर के बारे में जो प्राकृतिक कलर है उनकी चर्चा हुई है, ये सब है हम लोगों के पास। लेकिन क्या है कि हमको मिलाना पड़ेगा। ये आप देख रहे हैं, हमको सब जाना पहचाना है, कोई नई बात नहीं बता रहा। देखिए 4th सेंचुरी में हमने जो अभी ये पिलर बनाया है उसका जंग नहीं लगा, सब लोग सुने होंगे इसको। इसका मतलब कि आज के 1600 साल पहले हमारे पास एक ज्ञान विज्ञान था। देखिए 12वीं शताब्दी 13वीं शताब्दी में जो है ये हमको उस समय ये केमिस्ट्री का सब जानकारी थी, तो हमको जानकारी है ये सब। नेक्स्ट, अब हमें करना क्या है, उस ज्ञान विज्ञान को हमें जोड़ना है कहां से, जो अभी केमिस्ट्री का काम इधर शुरू हो रहा है कि केमिस्ट्री को वो जो एलिमेंट्स हैं उनको कैरेक्टराइज करना है, उनकी प्रॉपर केमिकल फाइंडिंग्स है, जो प्रॉपर्टीज है उसकी स्टडी करनी है, उनको ऑप्टिमाइज करना है, मतलब वो अपने मैक्सिमम रिजल्ट को दे सके, और फिर उनका असेसमेंट होगा कि वो कितना ठीक कर रहे हैं और तब उसका हम लोग स्केल करके मतलब इंडस्ट्रियल प्रोडक्शन कर सकते हैं। ये दिमाग में कहां से आती है बात, मैं एक 12वीं क्लास के बच्चे से बात कर रहा था कि वो मूर्तिकार है, हमने कहा कि तुम ऐसी मूर्ति क्यों नहीं बनाते जो पानी में अपने आप गल जाए, तो पूछा सर आप करते क्या, मैंने बताया मैं टीचर हूं फिजिक्स का, तो कहा प्रॉब्लम तो आपने खड़ी की है, समस्या हमसे पूछ रहे हैं। हमने पूछा क्यों भाई, हम कैसे प्रॉब्लम पे बात कर गए, कहा कि आप रिसर्च करने वाले लोग हो, अगर आप पीओपी नहीं बना के हमको देते तो हम पीओपी में क्यों बनाते, तो समस्या आपने खड़ी की तो समाधान भी आप कीजिए, और सर दैट वाज द थर्ड पॉइंट व्हेन आई डिसाइडेड टू डू समथिंग दिस वे। और इसी तरह से हर किसी को कहीं ना कहीं जुड़ना पड़ता है। इसमें ये जो देख रहे हैं आप बायोफ्यूल्स, हमारे यहाँ जैसे गुड़ है, कुछ ऐसे फल होते हैं, उनका जो अर्क होता है उसका इस्तेमाल होता है, ये अपने आईपीएस मतलब प्राचीन ज्ञान विज्ञान से पता है, पढ़ा दीजिए समय। इसी तरीके से देखिए कलर है, ये सब नेचुरल कलर है, हम कभी होली आ रही है सब लोग होली खेलेंगे और फिर सब वही आर्टिफिशियल कलर हम लोग यूज करेंगे, फिर बाद में जो है स्किन के डॉक्टर के पास दौड़ेंगे और तमाम और भी समस्याएं हैं। तो ये है समाधान हमारे पास है, बट हम उस तक पहुंच नहीं रहे। और फर्क क्या है देखिए कि अगर आप पीओपी एक एग्जाम्पल के तौर पे लिया गया है और कोई आप बायोकॉम्पोनेंट्स जो हमारे प्राचीन शास्त्रों को लिखते हैं, तो जहां बायोडिग्रेडेबिलिटी की बात आती है, ऐसी चीज जो कि अपने आप गल जाए, नष्ट हो जाए, वो हमारे प्राचीन जानकारी में है। पीओपी वैसा नहीं। ऐसे देखिए टॉक्सिसिटी, जो जहां पे मिलेगा जाकर उसको जो है टॉक्सिक जहरीला बना देगा, वो पीओपी में पड़ता है। स्ट्रेंथ उसकी अलग होती है, कल्चरल वैल्यू उसका कुछ भी नहीं है, पीओपी कोई प्रणाम नहीं करने वाला है, कच्ची मिट्टी को लोग प्रणाम कर लेते हैं, इवन गाय के गोबर से बनी हुई कोई चीज है उसको भी प्रणाम कर लेते हैं, क्योंकि आपको पता है गाय का जो गोबर होता है उसको गोमय बोलते हैं। आगे बढ़े मैडम, वो ये जरा आप देखिए बीच का जो जूमिंग किया हुआ जो चीज है आपको दिख रहा होगा, ऐसे आपको दिखेगा नहीं, लेकिन माइक्रोस्कोप से देखेंगे तो आपको ऐसे दिखेगा। ये जो अनडाइजेस्टेड प्लांट है इसमें क्ले मिलाते हैं और जो बैक्टीरियल बाइंडर्स होते हैं उनकी हेल्प से ये नेचुरल फाइबर का काम करता है, ये रिइंफोर्समेंट होता है और ये एक जैसे फिल्टर होता है ना, फिल्टर का काम करता है। इवन अगर ये गल जाता है पानी में जाकर जब, तो मछलियों के लिए खाना बन जाता है। तो सोचिए कि एक तरफ हमने उसको बनाया, यूज किया, डिजर्विंग किया और फिर वो किसी का भोजन बन गया, तो ये कुल मिलाकर एक ऐसा साइकिल बन जाता है जिससे कि हमें हेल्प मिलती है। ऐसे देखिए आपने इसका भी सुना होगा सीड गणेशा के बारे में, जो आप मूर्ति इस्तेमाल कर रहे हैं उसी में जो है सीड है, सीड को आपने डाला और फिर ये जो टर्मिनेट हुआ, तो ये फिर टर्मिनेट हो जाता है। इसको बोलते हैं विसर्जन से सृजन। पहले आपने विसर्जित किया, अब फिर वही सृजित हो गया। तो सृजन से विसर्जन, जो मैंने पहले कहा था कि जीना और मरना, हम आए हैं तो जाएंगे, तो एक तरीके से हम विसर्जित हुए और फिर सृजित हो गए, ये इसमें बताया गया है। नेक्स्ट, अब देखिए करना क्या है इसमें हम लोग को लैब, मैं सभी को इसमें आमंत्रित करता हूं। हम लोगों ने थोड़ा काम प्रारंभ किया है और हमारे डॉक्टर संजय शुक्ला जी हैं, उनके नेतृत्व में काम प्रारंभ किया है। इसमें मैं आप में से जितने लोग हैं, चाहे वो हिस्टोरियंस हैं, हिस्ट्री से जुड़े हैं, सोशियोलॉजी से जुड़े हैं, लिटरेचर से हैं, अपने आईपीएस को थोड़ा स्टडी करके, अपनी प्राचीन परंपराओं को स्टडी करके इसमें जुड़िए। आप सबके ही उसमें काम है, फिजिक्स के लिए भी काम है, केमिस्ट्री के लिए भी काम है, बायोलॉजी वालों के लिए भी काम है, और मुझे लगता है कि हम सब लोग मिलेंगे तो ये जो सॉल्यूशन है इसका वो होगा, हम ऐसे कंपाउंड को बना सकते हैं जो डिग्रेडेबल हो, जो टिकाऊ हो और जो हमारे नजरों में पवित्र भी हो। इस प्रकार से ये जो हमारे भावी रिसर्चर्स बैठे हुए हैं, आपके लिए भी स्टडी का पॉइंट है। आप लिटरेचर को संभालिए, देखिए, और जो काम कर रहे हैं इस फील्ड में, अगर आप उनके साथ जुड़ते हैं तो मुझे लगता है कि जो एक विचार आया है वो हम लोग पूरा करेंगे। यहाँ मैं बाकी लोगों की तरह मैं कुछ अपना रिसर्च बताने नहीं आया, क्योंकि मैं फिर वही रिसर्च अपना नॉन इन ऑप्टिक्स का बताता तो शायद वो ना मैं समझता ना आप समझते। तो मैं आपके सामने ओपन क्वेश्चन बस ये लेके आया हूं कि आपको ये देखना है कि अपने विषय को, अपनी एक्सपर्टीज को कैसे आप इस चीज से इंटीग्रेट कर सकते हैं। जैसे मुझे कभी लगता था कि मैं रिसर्च क्या कर सकता हूं, लेकिन आज मुझे नहीं लगता है कि मैं क्या कर सकता हूं। मैंने तय कर लिया है, शायद अगर आपको ये लगे कि आप इस फील्ड में कुछ कर सकते हैं, चाहे आपका विषय कुछ भी हो, तो आप सबका स्वागत है। आपने सुना, बहुत बहुत धन्यवाद। और फिर तय करना पड़ेगा तो कितने हमारे लिए। थैंक यू।
मिट्टी से जो ये मूर्तियां बनाई जाती है, गमले की मिट्टी से बन जाती हैं और वही विसर्जित भी हो जाती है बहुत ही आसान तरीके से। तो इसको भी आप लोग एक्सपेरिमेंट के तौर पे कर सकते हैं। और अब मैं फ्लैश टॉक जो है वो उसके कंक्लूजन के लिए एंड थैंक यू नोट के लिए सरोज रानी मैम को यहाँ पर बुलाना चाहूँगी।
Thank you, Dr. Abhay Kumar sir and Dr. Ram Kumar Tiwari sir, both of you, and giving us such a insightful and informative lecture. Your session on coordination, compound and green chemistry. Both lectures are highly enriching and full of valuable knowledge. You explained even complex concepts in such a clear, simple and engaging manners, and that way became easy to understand and interesting for all of us. We are truly grateful for your guidance, inspiration and for sharing your experience with us, and thank you so much sir, both of you, on behalf of Navdeep Kanya Mahavidyalaya.
मैं ये कहना चाहूँगी कि दूसरे जो सेशंस है वो दूसरे रूम्स में शुरू हो गए हैं, पोस्टर प्रेजेंटेशंस भी हो रहे हैं। तो काइंडली आप लोग अपने अपने स्थानों पे चले गए जो बच्चे यहाँ पर हैं। और जितने स्टूडेंट्स का इंटरनेशनल साइंटिफिक जर्नल्स एंड पब्लिशिंग हाउसेस in addition to a book, and several manuscripts are currently in press. Dr. Mitra serves as a reviewer and editorial board member for multiple internationally recognized journals, including those of the Royal Society of Chemistry, Elsevier, Sprinter, and Dental Science, among others. He is also an active active member of Board of Studies and syllabus committee member for postgraduate chemistry programs, and has successfully supervised over 30 postgraduate students in completing their MSc dissertations. Dr. Mitra is deeply committed to chemistry education and is an elected member of Executive Council of the Association of Chemistry Teachers, headquartered at Homi Bhabha Center of Science Education, TIFR Mumbai, a position he has held since January 2020. His association with Indian National Chemistry Olympiad began in 2019. In 2024, he was appointed by the National Coordinator Science Olympiads, Government of India, as a scientific observer and jury member for the Indian delegation at the International Chemistry Olympiad held in Riyadh, Saudi Arabia. In 2025, he was appointed to serve in the same capacity for the Indian delegation at the ICHO held in Dubai. He is also recognized as a resource person for the Vigyan Pratibha Teachers Training Workshop at NISCR Bhubaneswar and IISCR Kolkata, an initiative under the Department of Atomic Energy. It's a very long and illustrious CV, and though I don't want to shorten it up and I want everybody to listen it, but still, very sorry sir, I'm just cutting it short. Mr. Mitra is heading, and he is regularly entrusted with the confidential academic responsibilities by the Ministry of Education, Government of India, which he has consistently carried out with distinction. We are really very much privileged to have you here, sir, and I would like you to come up on the dais and say some words here.
Thank you very much for your kind introduction, and I would like to thank all the organizers present over here, especially Dr. Neha Agarwal Madam for inviting me in this international conference, and I wish all the best to this particular conference. Thank you.
Now I shall invite our presenters, and then after the first presentation, I will introduce our co-chair. Okay? Shall we call upon Jolly Yadav here? And I would.
जो वो प्रयोग करते हैं तो हमारे जो आगे आने वाले जनरेशन हैं उनको बेनिफिट मिलेगा। तो मैंने इसमें वैसे मैं एजुकेशन डिपार्टमेंट से हूँ और इसलिए मैंने इसको कहीं न कहीं शिक्षा से जोड़ने की कोशिश करी है। तो नेविगेटिंग ह्यूमन डायमेंशन सोशल साइंसेस एंड बिहेवियरल स्टडीज एंड कैटलिस्ट फॉर सस्टेनेबिलिटी, जो मैंने ये पेपर लिखा हुआ है उसमें हमारा जो मेन अचीव करने का मतलब है वो sustainability, meeting present needs without compromising future generations. Each fundamentally a human challenge, not merely a technological or ecological one. While the biophysical limits of our planet are well documented by the natural sciences, the drives of the unsustainable practices are deeply embedded in social structures, cultures, norms, economic system, and individuals' psychological constituents. This research posits that the social and behavioral sciences are not ancillary but central to the sustainability projects that a comprehensive review and synthesis of the literature from sociology, psychology, anthropology, economics, and political sciences. This paper explored three core themes of this. Understanding the roots of unsustainability, examine how social norms, values, inequalities, and institutional frameworks produce unsustainable system. Analysis and influencing behavioral changes. Elaborating the theories and intervention aimed at shifting individual and collective action towards pro-environment outcomes. Remaining institution and governance for sustainability. Investigating pathway for transforming economic model, policies, framework, and governance structure. The paper, equitable and cultural resonant sustainability strategies moving beyond the focus on fixing and the environment for transforming the social world that shapes our relationship with it. जो यहाँ पे हम लोग ये समझना चाह रहे थे कि कैसे इसको सस्टेन करें, तो हम लोगों का ये मतलब नहीं कि किसी यहाँ पे ये जंग नहीं चल रही है कि ह्यूमन वर्सेस टू एनवायरनमेंट, बट हमें कहीं ना कहीं जो ह्यूमन बीइंग्स या इनका बिहेवियर है, जो हमारी लाइफ स्टाइल है, उसको कहीं ना कहीं एनवायरनमेंट के इक्वल करने की बात करने की कोशिश करी है। तो पहला हमारा जो है तो वो इम्परेटिव ऑफ द ह्यूमन डायमेंशन को समझना होगा, अंडरस्टैंडिंग द रूट्स ऑफ अनसस्टेनेबिलिटी। हमें ये जानना होगा कि हमारी जो रूट्स हैं वो कैसे सस्टेन की जाए, सोशल स्ट्रक्चर्स, कल्चर एंड इनइक्वालिटी को नॉर्मल कर करके। द सोशलॉजी की लेंस नॉर्म्स, वैल्यूज और सिस्टम को समझ करके, सोशल प्रैक्टिसेस के थ्रू, वैल्यूज और वर्ल्ड वाइड्स के थ्रू, द इकोनॉमिक लेंस मार्केट, एक्सटर्नल एंड बियॉन्ड। हम लोग क्या करते हैं कि चीज़ों को किसी भी तरह एक्सप्लोर करने के लिए तरह तरह के ऐसे केमिकल्स बनाते हैं जो बहुत ही ज़्यादा ह्यूमन लाइफ को इफेक्टेड करते हैं. The equity and justice lies in equity and vulnerability, environmental justice, climate vulnerability, global inequality. Analyzing the influencer behavior change from news to deep engagement. जब तक हम सभी इंगेज नहीं होंगे इन सब सारी एक्टिविटीज में, तब तक हम कभी भी कुछ भी अच्छा फाइंड आउट नहीं कर सकते हैं. Beyond rational choice, inside conflict. Okay, thank you, ma'am.
Modifications of proteins with a strong emphasis on molecular mechanism underlying cancer progression. Dr. Srivastava obtained his PhD in biotechnology from the National Institute of Immunology, New Delhi, and Autonomous Institute of the Department of Biotechnology, Government of India. His doctoral research elucidated the functional implications of BLM helicase phosphorylation by checkpoint kinase 2, resulting in 6 high-impact publications in reputed international journals. He subsequently pursued postdoctoral research at the CSIR Institute of Genomics and Integrated Biology, New Delhi, under the ADBT Wellcome Trust funded project. Dr. Srivastava has been awarded a DST SERB Teachers Associateship for Research Excellence project and is currently principal investigator on the ongoing ICMR funded research project. He has published more than 30 papers extensively in peer-reviewed international journals and holds one granted patent. Dr. Srivastava is the recipient of several national and international awards and is a life member of prestigious scientific bodies including the Indian Association of Nuclear Chemists and Allied Scientists, Indian Society of Chemists, Biologists, Royal Society of Biology, UK, Indian Science Congress Association, Indian Association for Cancer Research and the Society for Biotechnologists. We welcome you, sir.
Participate in the conference. So I'm Dr. University, so my area of research in the cancer biology and the life history. So those who are interested in the cancer biology area, so here she can collaborate with me and we can work together. This is the basically motto of the conference. So thank you so much for that.
Want to give some introduction on green chemistry? Green chemistry is simply the set of principles as given by Anastas, which given by Anastas, and in green chemistry of 12 principles, out of 12 principles, he has given one point about the catalyst.
metal oxide, cold shell, and single atoms. Now, a brief introduction of the synthesis of nanocatalysis from top-down approach and bottom-up approach. Now, I am going to especially deal with the green synthesis, that is from plant as well as microorganism. So, on the next slide is microbes and plant extracts. We can synthesize green synthesis of nanocatalysts. The following are the bacteria, fungi, and algae in microbes, and the plant extracts are from stem and leaves, which are used to synthesize many nanoparticles such as silver and gold. Now, some green applications of nanocatalysis. They can be used as photocatalytic and for treatment of wastewater and industrial effluents. Now, there are certain challenges that deals with the synthesis of nanocatalysis, as they are very nanostructured, so their synthesis cannot be done, it cannot be controlled, and it is thermally unstable. And there is a high possibility of falling due to large surface area, so we need to overcome these challenges. Now, finally, I conclude that it is more efficient over traditional catalytic systems such as homogeneous and heterogeneous. So we need to work upon these challenges and improve our synthetic applications so that we can deal with nanocatalysis and use them in the future.
और इस ऑडिटोरियम में जो अंतर्राष्ट्रीय सम्मेलन में उपस्थित हैं सभी को नमस्कार। और जैसा कि जस्ट इसके पहले भी बात हुई कि जो फैकल्टी ऑफ सोशल साइंस से हैं सब्जेक्ट्स के अलग अलग वो भी किस तरह से साइंस को समझ सकते हैं, या क्योंकि मल्टीडिसिप्लिनरी था तो इससे कैसे हम लोग कनेक्ट कर सकते हैं और क्या सॉल्यूशंस दे सकते हैं। तो मैंने इसको सिक आइडियोलॉजी से जोड़ते हुए एक अपना छोटा सा पेपर तैयार किया है। मुझे उम्मीद है कि हाँ कुछ ना कुछ इसमें नया लेकर के जाएंगे। माय टॉपिक फॉर प्रेजेंटेशन इज सर्वर द भला एंड सस्टेनेबल साइंस, अ सिक एथिकल फ्रेमवर्क फॉर केमिकल इनोवेशन। The relationship between science and ethics has become one of the most important discussions of the today. While chemical sciences have transformed modern life through medicines, agriculture, industry, and technology, they have also contributed to pollution, climate change, resource depletion, and ecological imbalance. These challenges show that scientific progress cannot remain value neutral. The future demands a model of science that is guided by ethical responsibility and sustainability. In this context, the SIG principle of Sarvata Bhala, meaning the welfare of all, offers a powerful moral framework for rethinking the goals of chemical innovation and sustainable scientific development. SIG philosophy presents a holistic understanding of the universe, in which human beings and nature are deeply interconnected. The foundational concept of Ek Onkar emphasizes the unity of all creation. This worldview challenges the modern tendency to treat nature merely as a source for exploitation. Instead, it encourages respect, balance, and responsibility toward the environment. When applied to scientific activity, this principle suggests that research and technological advancement must consider their broader ecological and social impact. Another key idea in Sikh thought is Hukum, the cosmic order that governs the universe. This concept highlights the importance of harmony and balance in natural systems. Environmental degradation, excessive industrialization, and unsustainable chemical practices can be understood as violations of this balance. From this perspective, sustainability is not only a technical challenge, but also a moral duty to live and work The concept of Sarbat ka Bhala extends this ethical responsibility further. It calls for the welfare of all beings, including present and future generations. This idea closely aligns with the modern concept of sustainable development, which seeks to meet present needs without compromising the ability of future generations to meet their own. When scientific research is guided by the principle of universal welfare, its goals shift from profit-driven innovation to socially responsible and environmentally conscious development. Chemical sciences provide a strong example of why such an ethical framework is necessary. Industrial chemical production has enabled large-scale agriculture, advanced pharmaceuticals, and modern materials. But it has also produced toxic waste, polluted water systems, and contributed to climate change. The rise of plastic pollution and hazardous chemical residues demonstrates the urgent need for a new scientific paradigm. Green chemistry has emerged as a response to this crisis by promoting waste reduction, renewable resources, safer chemicals, and energy efficiency. Interestingly, these goals resonate deeply with Sikh ethical teachings that emphasize harmony, compassion, and responsible living. The Sikh idea of seva or selfless service offers an inspiring way to reimagine scientific practice. When science becomes a form of service, innovation is directed towards solving human and environmental problems rather than maximizing profit alone. This approach encourages the development of clean energy technologies, eco-friendly materials, safe medicines, and sustainable agricultural practices. In this sense, scientific research becomes a tool for collective well-being rather than individual gain. An important aspect of sustainability is intergenerational responsibility. For future generations have a right to inherit a healthy planet with clean air, safe water, and stable ecosystems. Sikh teachings encourage long-term thinking and responsible actions that benefits not only the present but also the future. This perspective strengthens the ethical foundation of sustainable science by linking scientific responsibility with moral accountability. Integrating Sikh ethical principles with chemical sciences create a powerful interdisciplinary model for sustainable development. Such a model emphasizes ecological unity, collective welfare, responsible consumption, and harmony with nature. It encourages scientists, policymakers, and educators to work together in building a future where innovation serves humanity and the environment simultaneously. At the end, I would like to say the environmental challenges of the modern world cannot be solved by technology alone. They require a combination of scientific knowledge and ethical wisdom. The principle of Sarbat ka Bhala provides a meaningful moral framework that aligns closely with the goals of sustainable and green chemistry. By integrating spiritual values with scientific innovation, humanity can move toward a future where progress is measured not only by technological advancement but also by the well-being of all living beings and the health of the planet. Thank you so much.
स्टेबल भी ज़्यादा है पेरेंट की कंपैरिजन में जो ज़्यादा हमारा जो फोकस है वो ज़्यादा बॉडी को हर जगह हमारी बॉडी से कैमरा पे ब्लॉक हो जा रहा है जिसकी एक्सेसिबिलिटी भी बढ़ रही है हमारे पेरेंट्स की कंपैरिजन इससे ये हम कंफर्म कर पा रहे हैं कि जो हमारा ज़्यादा है वो ज़्यादा यूज है हमारे पेरेंट्स यहाँ तक नीचे भी कर लीजिएगा
Pharmacy and you don't have to they don't ask you for any prescription or anything. You just go. For example, you just say that you want a paracetamol. You don't even know what sort of dosage, what amount of dosage your body requires.
farmers have to be in process of presentation training?
After the
Department of Physics, University of Lucknow. Today I stand here to present my works titled Integrated in Silico and Integrating Vitro Evaluation of 1 and 3 methylene pyridine phenylamine targeting VGFR, EGFR and resistance. First of all, I would like to give brief introduction of my work. From the literature survey, we found that the indole and pyridine are the promising scaffold in drug discovery. So that we have taken a hybridized molecule which enhance the anti-cancer activity. As we know, cancer involves multiple signaling pathways. So multi-targeted cancer activity is a strategic therapeutical process. There we used different methods. Methodology involved is there is a flow chart which I showed there. First of all, we optimize the molecule. These three types of algae, I have set up three different types of
are described. This one. For different type of interaction, we can classify different values of constants A and B for population. क्योंकि दोनों ही population एक दूसरे की growth को inhibit कर रहे हैं, then this is there will be population between two populations. So both A and B will be negative. And governance में एक population तो दूसरे की growth को promote कर रहा है, लेकिन दूसरे पे कोई भी effect नहीं पड़ रहा है. ऐसे म्यूचुअलिज्म में दोनों ही पॉपुलेशन एक दूसरे की ग्रोथ को प्रमोट करते हैं. एनालिसिस में एक पॉपुलेशन दूसरे की ग्रोथ को इनहिबिट कर रहा है, लेकिन दूसरे पे कोई इफेक्ट नहीं पड़ रहा. सो दिस इज द बेसिक स्ट्रक्चर हाउ कैन वी मॉडल एनी कर्व सिस्टम इन मैथमेटिक्स. बाकी तो आगे इसमें एनालिसिस में थैंक यू. One question can be taken from the audience.
As we all know, the regioselective ring opening of aziridine is an important transformation for the accessibility of 1,2 bicyclic code. Traditionally, this was achieved using different types of metals such as zinc, platinum, palladium, ruthenium, iridium. However, with the emergence of visible light photoredox catalysis, the approach has shifted to a much milder approach. But now also the system is heavily reliant on metals such as iridium and ruthenium. The main drawback of these metal systems is that they are very costly, highly toxic in the system, and most of it is metal leaching in those systems. So it was highly desirable to develop a system which is metal free. So through the literature study, our team has worked on graphitic carbon nitride. Pristine graphitic carbon nitride suffers from rapid electron loop recombination, which leads to the inefficient charge separation for the absorption of visible light. On the CO group in the Earth's carbon nitrogen network, it was seen that the yield increased dramatically from 51% to 95%. So,
and I will talk on very specific topic, that is adaptation. Adaptation is one of the biggest problem of our country. You know, everything is violated in this time, and government unable to control the adaptation of food. And one of the components of food is fire. So just I plan to analyze how this iron retention can be detected and how it can be used for energy sources. Okay. So just I want to explain some basic concept of iron retention, detection and conversion of this adulterated iron into energy sources. So adulteration is addition of certain unwanted things, addition of certain poisoning things in our food or oil. You know, iron, this word adulteration is appropriate only when the adulterates are toxic. But if adulterates are edible, then it will create confusion in whether these things are adulterated or not. So, when we use certain illegal drugs such as cocaine, heroin, methamphetamine, then such drugs are called cutting-edge drugs. And the use of such type of drugs in extra amount causes poison. Illegal drugs and cutting edge, they are different. These are certain illegal drugs which are used in our society, such as heroin, cannabis, and methamphetamine. And cutting edge drugs are mostly added to take benefits in drugs. So these are certain cutting edge drugs which are added to the either medicine or other things. So, iron adulteration is concerned, the addition of cheapest iron to take extra benefit, to take other financial benefit. If cheaper oil are added in edible oil, then such oil are said to be the iron adulteration. If you are thinking about that, what happens when you take adulterated oil? It creates lots of problems. It damages our organs. It shows the allergic reaction. It shows nutritional deficiency, digestive problems, as well as certain diseases such as cancer, bronchitis, asthma, etc. So, in order to analyze, there are three types of analysis of this adulterated iron. One is the visual impression, other is the chemical testing, and the last one is the database analysis.
Sir, if you come to the findings.
Okay. And biggest problem is that मान लीजिए कि आपका आयल एडल्टरेटेड है, तो उस एडल्टरेटेड आयल को करेंगे क्या? जो हमारी फाइंडिंग है वो है, फाइनली आपको दो शब्द में बता देना चाहता हूँ कि अगर आयल एडल्टरेटेड है, अगर उसको पानी में डिस्पोज आप करते हैं किसी तरह के पानी में, नदी में, समुद्र में, तो जो कि आयल जो है ऑर्गेनिक मैटर होता है, तो ये वहाँ से ग्रीन गैसेज का इवोल्यूशन लगभग 80% लगभग करता है, जो कि वहाँ के ऑर्गेनिज्म के लिए हार्मफुल है। अगर हम उस सॉइल को सॉइल में डाल देते हैं उसको डिस्पोज करने के लिए, तो सॉइल ही पोल्यूटेड हो जाता है, इवन ड्रिंकिंग वाटर आपका पोल्यूटेड हो जाता है। तो बिगेस्ट प्रॉब्लम है कि जो आज समोसा बनाने के बाद लेट होकर उठी आयल है, उसका क्या किया जाए? या अदरवाइज जो लोग मिलावट करके बेच रहे हैं, जैसे मस्टर्ड ऑयल में आर्जिमोन ऑयल मिला देते हैं, तो उस ऑयल को अगर हम पता भी कर लेते हैं कि ये ऑयल एडिटेड है, तो उसको क्या किया जाए, ये बिगेस्ट प्रॉब्लम है। तो ये प्रॉब्लम कंट्री के सामने है और नोबडी आर एबल टू रिजॉल्व दिस इशू। तो मैंने इस काम को चैलेंज में लिया और मैंने IIT देहरादून के साइंटिस्ट से मिल करके इसमें बात किया। तो इसमें जो है इस बात में ये फाइंड आउट किया कि जो एडिटेड ऑयल है उसको हम क्या करते हैं कि ट्रांसस्पिरिफिकेशन करते हैं। तो जब ट्रांसस्पिरिफिकेशन करके हम इसको बायोडीजल में कन्वर्ट करते थे। एक तो हम एडिटेड ऑयल को रीयूज करके एनर्जी पर्पस यूज करते हैं, बायोडीजल फॉर्मेशन करके हम उससे एरोप्लेन का ऑयल भी बनाते हैं और उससे आप चाहें तो और भी वेराइटीज हैं उसका इस्तेमाल उसको अलग टाइप ऑफ ट्रांसस्पिरिफिकेशन करके हम यूज करते हैं और इस तरह से हमारा ऑयल का एनर्जी सोर्स में कन्वर्ट होता है। थैंक यू मैम, थैंक यू।
And the incidence of secondary primary cancers in females.
इसमें दो तरह के जैसे सिंड्रोम्स होते हैं, जो जीन सिंड्रोम्स होते हैं, इसमें जो चेंजेस होते हैं एक बार कैंसर होने के बाद, तो वो कितना रिस्क इंक्रीज करते हैं इसी के ऊपर कोई रिसर्च है। रिस्क फैक्टर कितने लेवल तक बढ़ जाता है ये हमको देखना है कि अगर एक बार जीन्स में चेंजेस हो गए तो नेक्स्ट टाइम दूसरे जीन्स में बॉडी के कितने ज़्यादा चेंजेस पॉसिबिलिटीज बढ़ाता है या इंक्रीज करता है उसके रिस्क। ऑन्कोलॉजी डिपार्टमेंट में इस तरह की कई रिसर्चेस हुई जिसमें ये बताया गया कि रिस्क फैक्टर जो है 40 इयर्स की फीमेल्स में कितना ज़्यादा बढ़ जाता है। इस पर ऐसी साल में यूके में रिसर्च भी जिसमें रिप्रेजेंट किया गया 8500 फीमेल्स का पेशेंट का डेटा जिसमें रीम्यूटेशंस होने के रिस्क फैक्टर इंक्रीज हुए। Genetic research acts as a biological bridge between the different types of cancer. A single diagnosis in a woman with a genetic prediction is a rarely in the isolated event. Feature the oncology must provide broad, often specialist treatment for the gene-specific prevalent to lower and mortality rate in secondary cancers. Thank you.
Environmental degradation on physical fitness and public health. This theme is based under like sub-theme health, environment, and one health and coaching. The first slide is like environmental health access. Environmental degradation की क्या causes है like environmental degradations like industrialization, urbanization, climate changes, environmental degradation, and has emerged a critical threat like physical fitness, public health, polluted air, literacy day by day, great diseases, and extreme weather conditions create barriers to active living and impair physiological function.
दूर नहीं जाना है भाई।
Some are the environmental stressors like air pollution, climate change, urbanization, and unsafe environments. Air pollution like particulate matters, toxic emissions, like they are causing respiratory functions reducing in the players and in the normal people also. Climate changes like rising temperature, heat wave, limit indoor activities. like climate change जैसे है कि day by day temperature increase हो रहा है, तो उससे क्या हो रहा है
some more.
एयर पोल्यूशन जैसे कि साइलेंटली क्या कर रहा है, परफॉर्मेंस को डिग्रेड कर रहा है, जैसे कि रिड्यूस एडवोकेट कैपेसिटीज, इम्प्लीमेंट डेवलपमेंट, एजुकेशनल चैलेंजेस फॉर कोचेस और प्लेयर्स आल्सो. नेक्स्ट प्लीज. क्लाइमेट चेंजेस की वजह से हमारा हीट बढ़ रहा है, टेम्परेचर इंक्रीज हो रहा है, जिसकी वजह से हीट स्ट्रोक बढ़ रहा है, हार्ट स्ट्रोक, जैसे कि हार्ट में हम पहले सुनते थे, आज के टाइम पर हीट स्ट्रोक के केसेस बहुत सारे सुनने में आ रहे हैं. जैसे कि गर्मी आएगा तो उसमें क्या होता है कि इंटरनली वाटर लेवल कम हो जाता है और एक्सेसिव स्वेटिंग होती है, जिससे और हीट टेम्परेचर बढ़ जाता है बॉडी का, जिसकी वजह से हीट स्ट्रोक बढ़ता है और डायरेक्टली वो डेथ भी हो जाता है. नेक्स्ट like some green space activities का जिम्मा नहीं है कि जैसे कि फिजिकल एक्टिविटी करेंगे हम ग्राउंड में जाएंगे.
Last like इधर point it was a nice presentation.
like बस लास्ट में यही है कि सस्टेनेबल डेवलपमेंट में चाहिए हेल्थ और एनवायरनमेंट में बैलेंस बना के रखना पड़ेगा हमें और ग्राउंड्स अवेलेबल कराने पड़ेंगे और ग्रीन एरिया का स्पेसेस प्रोवाइड करना पड़ेगा और बच्चों को और हर एज ग्रुप को मोटिवेट करना पड़ेगा फॉर द फिजिकली फिट. थैंक यू सो मच.
Human resources in the impact of conflict towards the influence in India towards the environmental sustainability. So we are going to discuss about why environmental sustainability matters, the role of sustainability, green, environment and its practices, and also environmental behavior, the ecosystem, and also the managers. So moving forward because of time, I'm going to give a little brief introduction on ANRF. Okay, sorry. I'm going to give a little bit introduction on what is green hydrogen. Not green hydrogen, but the green human resources management and organizations. When we are talking about green human resource management, we have to talk about this has to be about the human resource management practices that organization has to take on the employees and that has to sustain the Okay, moving forward on the next slide. Okay, so we're going to talk about the methodology. This means that something that So on the methodology, this is something that when it comes to green human resources management, we have a lot of things that is going on, and with employees within an organization, these are the people that we really have to focus on, because as a managing an organization, you have to make sure that you have practices that is impacting the employees, and without an employees in the organizations, you cannot do much about it. So with these ones, with the methodology, you have to yourself to do the journal articles, most of you want to have information in how it should affect the employees, that they can not retire back, but also to make sure that there are practices that are within an organization to affect within an organization in this environment. So the implications for the mental managers, okay, conclusion. So, we are going to conclusion. Last slide. Okay, let me say on our conclusion, we have to say that nothing like it's not getting. Let me just say that on conclusions, we have to say that we are living in the world whereby we have to, the green has to take over, and we have to sustain the environment and the environmental, because without the environment, without taking care of the environmental, we cannot go anywhere. So we have to make sure that we conserve the sustainability, or we have to serve the ecosystems. We have to make sure that we have practices that has to conserve environmental for the generations to come, and also to make sure that with the green practices, it has to impact the system. Let me say this
The title of the presentation is Re-Realizing Outside Particle-Based Electrochemical Sensing Platform for Highly Sensitive Detection of Cadmium in Water Samples. Cadmium is the most dangerous, high toxic metal, so we explore the environmental contaminant, and in Japan, cadmium has found the cause dialysis hypertension. We have detected the next. Number 13. We have detected the calcium ion in water samples. The found that it has very low limit of detection. Low limit detection 0.012 micromolar, and the linear range of detection 1 micromolar to 5,000 micromolar is the large detection range. Data sensitivity also good, remarkable sensitivity 1.2340 microampere micromolar in 1 centimeter square minus 2. Next. And this is the published difference data. Our sensor is good for the sensitivity and the limit of detection. This is our conclusion. The zinc oxide and the zinc oxide ICO nanoparticle is the green-derived method from the orange peel extracts, and the characterization various microscopic and spectroscopic tools in previous slides, and the sensor also would display the reproducibility, interference and stability under optimization conditions. So thank you.
Public Health branch from National University. So first we're just going to go through my slides fast, and then I'm going to give you an overall of what's happening there. So my topic is From Pollutant to Policy and AI toolkit for weighing the health and economic burden of chemical exposure. Let's just first go through the slide. So this is the problem. Continue, please continue. Yes, these are the residuals, which are just pretty much the root of the problem. And then we have the legal consequences. Please continue. And then our proposal, which is the health toolkit. Continue. And this is the health toolkit design. This is exactly how it's going to be. Please continue. And then there are 3 modules that are part of this. Continue. Module 1. So we have 3 modules, module 1, module 2, and then module 3 as part of this. Okay, so as this sliding, let me just give you an overall of what we are doing. So what we're saying is that we're removing the focus from measuring health impact of chemical substances from evaluating what the chemicals do to actually see how the human lives actually being impacted. So chemical policy is currently measuring emissions but rarely quantifies health and economic burden. So our work here is to propose an AI-driven health and economic burden toolkit integrating exposure modules, health projections, and economic evaluation. It also allows policymakers to test scenarios and understand how the regulations translate into reducing diseases and financial savings. By linking environmental data currently to societal outcomes, it supports more preventative and equitable decision making, because ultimately successful chemical policy should be measured by healthier communities, not only measured. With that, we'd like to conclude this presentation. Thank you so much.
That was specialized. Now, Carol. Dental. That's dental.
सोच लियो भाई.
Student from Lucknow University. Due to time constraints, I'm just going to be
as brief as I can. The title of my presentation is the role of green chemistry in enhancing occupational and environmental health for sustainable future. In public health, prevention is a cornerstone. So is in green chemistry. The concept is the same. Green chemistry basically refers to designing of safer chemical products that reduces or eliminates the use or generation of hazardous substances. It focuses on prevention. Prevention at source. This means we protect workers before exposure happens. At the same time, we are protecting our environment. Next. In relevance to occupational health, green chemistry protects workers in workplaces, like I mentioned. It reduces toxicity that comes with chemical processes. This eventually leads to fewer accidents in workplaces, lowering the risk of long-term health effects. Next. Similarly, when safer chemicals are designed, it means less toxic waste released in the environment, protecting our air, protecting our soil, and protecting our water. Prevention at source reduces pollution and protects ecosystems and public health. Real-world application and policy relevance. Green chemistry is a very good aspect because when we know how green chemistry works, the real question now comes: how fast can we scale it? We see in pharmaceutical manufacturing companies nowadays greener synthesis of medicines, which means there's less toxicity, the use of less toxic solvents, which means there is less waste that is going to our environment, and there's also a production of biodegradable cleaners. In agriculture also, the use of less toxic pesticides is much common, much thanks to green chemistry. Next. In conclusion, green chemistry is a very vital tool when it comes to environmental health as well as occupational health, because our health is impacted by where we work and the surroundings around us. As father of green chemistry says, St. Paul Anastas, green chemistry is not luxury, it is a necessity. It is not just the environment solution, it is an economic imperative. Thank you so much for your attention.
Thank you. That is the characteristics of one is into two patterns. Or simply we can say that EFI. As we know that the traditional painkillers or non-steroids anti-inflammatory drugs are forced to trade off between stomach health and heart health. My work uses the combination of a density functional theory or molecular dynamic simulation to show the specific fluorosubstituted endone act as a dual inhibitor targeting both COX-1 and COX-2. This dual action aims to maintain high anti-inflammatory efficiency and reduces the common side effect. Objective of this work is to evaluate the compound as dual inhibitor of COX. Firstly, we perform the characterization using a DFT analysis, electronic property, molecular docking, and simulation, and then ATMAT prediction and toxicity prediction. In the DFT results, as you can see that the optimization will show the stable ground state with the lowest ground state energy of 730.29 Hz. Next slide. The calculated energy gap is 4.49, indicated high caloric reactivity or the softness of molecular softness. On the right hand side, as you see the MESP map, the red is an electron region on the oxygen and fluorine show the electrophilic side, and electron transition region on NH shows the neutrophilic side. As we move forward to the vibrational analysis, we can see that there is a good agreement theoretical and experimental at the IR, which confirms the good agreement between structure, docking. Molecular docking is a technique to investigate the best configuration of ligand bind within the binding pocket of receptors. The interaction pattern between ligand and site coincide in potential biological outcomes, especially ligand activity versus targeted product. As with the docking result, we can see that there is a strong binding affinity of COX-1, 3 and 3 and COX-1 and 4-1 with the binding affinity of 7.4, 7.0, 7.1 and 6.8. And as you can see that there is a key hydrogen bond that was also observed with the important active residues, that is SER530, YR385 and PRG120. And there is also hydrophobic interaction which shows the which also stabilize the complex. The molecular diamond formulation also confirms the stable protein and ligand complex throughout the 100 nanoseconds. And as you see to the graph of RMST or radar utilization indicate a compact and stable structure. ATMAT properties protection also shows a good oral bioavailability and absorption lightness. And there is my compound follow all the rules and show no productive toxicity, suggesting a stable pharmacological profile. In conclusion, I can say that my compound is not only theoretical stable but also the pharmaceutical active, and its ability to remain bound to its COX active under over the 100 nanosecond time frame. We can consider that it is a strong lead compound for next generation and thank you.
They didn't present their own research work, rather they basically gave a presentation based on an overview on nanotechnology or different type of topics. So my suggestion will be, since it's a wonderful forum to discuss your own research work, and yesterday during my presentation I was elaborating that how an UG or PG student can perform different type of research works. So my suggestion will be, it will be a wonderful opportunity for you and also for your institute if you can do small project-based work and you can present your work in this type of conferences. And if you wish, you can also publish those science education related journals. Okay, thank you.
So would you like to say something? Please.
On bridging disciplines to chemical sciences for a sustainable future. On the behalf of Inter-Navik Kanna and the conclusion of the conference summarize threshold achievements, knowledge, Professor Ajay Sir, Vice Chancellor of Parliament, function of our guest. Today we are having Professor Ajay Dareja sir as our chief guest, and I'll request our ma'am to please do the honors. Meanwhile, I'll just brief about sir. Has more than 33 years of teaching and research experience in subject chemistry. Learning specifically designated as Vice Chancellor, Harvard has more than 170 published international chapters, 40 international journals, and 55 research. Sir,
pleased to share a short report of the conference. I am pleased to share that it was presided over by J.P. Saini Sir, Vice Chancellor, University of Lucknow. The chief guest, Honorable Shri Sunil Kumar Sharma Sir, Minister of Information Technology, Government of Uttar Pradesh, emphasized the vital role of chemical sciences in sustainable development through green technologies and resource optimization. The distinguished guests, Professor Rajkumar Mittal, Vice Chancellor of Baba Saheb Bhimrao Ambedkar University, highlighted the importance of science and technology for inclusive and environmentally balanced growth. The international keynote speaker, Professor Shrikanta Babu Janalagatta from University of KwaZulu-Natal, South Africa, he described chemistry as foundational to innovation and human life. Other notable attendees of the inaugural session were Professor Ashwini Kumar Mishra Sir, Regional Higher Education Officer, Professor Shiv Kumar Mishra, Amarkantak University, Professor Devendra Singh, Ambedkar Nagar, Dr. Abhishek Avasti from Madhya Pradesh, Professor Upma Chaturvedi, Principal Our Girls Degree College, PG College, and Dr. Amit Krishna Mitra from West Bengal, Dr. Anurag Patil from Mumbai University, Dr. Abhinanda Shrivastava from Bhimrao Ambedkar Bihar University, Professor Surendra Prasad from University of South Pacific, PG, Suva. They all came a long way for attending the conference. Apart from that, we had many other dignified personalities in the inaugural session, whose name I have not mentioned due to shortage of time. During the session, the two edited volumes published by Springer Nature, Taylor and Francis book, that was my publications only, along with the two books edited by Dr. Sunita Singh and one by Professor Seema Pandey, and the seminar survey was released. The session was successfully conducted by Professor Vinita Singh and was conducted by co-convener and IQAC coordinator, and was concluded by IQAC coordinator and co-convener of this conference, Professor Sangeeta Bhutwa. The second session featured a panel discussion moderated by Dr. Sukmani Gandhi. Esteemed panelists included Professor Dhruv Sen Singh, Head Department of Geology, University of Lucknow, Professor Nishi Pandey, Professor of Eminence, University of Lucknow. She was the chair of this session. Professor Deepa Dwivedi from Bhimrao Ambedkar University, Lucknow, Baba Saheb Bhimrao Ambedkar University. Professor Ramesh Yangar, he is the General Secretary of the Association of Chemistry Teachers, Mumbai, and Dr. Manisha Shukla from Department of Chemistry, University of Lucknow. They were present. She was present as discussant. The panelists share insightful views on sustainable development, emphasizing the importance of balancing economic growth and environmental conservation and responsible resource utilization. The third session featured plenary discussions, where the keynote speaker, Professor Shrikanta Babu Janalagatta, delivered a talk on green chemistry and sustainability, emphasizing the responsibility of chemical sciences to pursue continuous research aligned with environmental protection. The second invited talk was delivered by Professor A.K. Saxena, the chairman of GIPER and the former dean of NIPER, who shared case studies on drug design strategies from discovery to development. Professor Surendra Prasad from University of South Pacific, Australia, he delivered a plenary lecture on bridging chemistry to environmental analysis for sustainable future, focusing on the pivotal role of chemical sciences in environmental monitoring and sustainability. This was followed by plenary lecture 4 by Dr. Amit Krishna Mitra, Officer West Bengal Education Service and the founder head of Government Degree College, Singapore. He presented his talk on the transforming the laboratory into a hub for advancing chemistry education in India, where he highlighted innovative approaches to enhance chemistry education across the country. The second day, this was followed by technical sessions. We had number of sessions because we had received more than 600 registrations in the conference, and we had 6 technical sessions, that is 3 in online mode, 3 offline mode, and we had 6 technical sessions in online mode also, that is total 12. In total we have 12 technical sessions along with 2 poster presentations. So the second day of the conference commenced with a special invited talk by the President of International Union of Pure and Applied Chemistry. I repeat, the second session was started by the President of International Union of Pure and Applied Chemistry, Emeritus Professor, Professor Mary Larson, that added another feather to our cap. On the center of the theme, theme of the seminar, she highlighted the pivotal role of chemistry in bridging disciplines for a sustainable future and emphasized its relevance to global initiatives, particularly the IUPAC Global Women's Breakfast, which is celebrated worldwide to promote diversity and inclusion in the chemical sciences. Plenary Lecture 5 was delivered by Dr. Anirudh Balakrishna Patil, Assistant Professor from University of Mumbai, on the topic Structural Reengineering of Mesocomposite Materials for Sensor Applications, highlighting advances in material design for innovative sensor technologies. This was followed by Plenary Lecture 6 by Professor Ajay Visesa, School of Agriculture and Science, University of KwaZulu-Natal, on rejuvenation of cellulose-based insulating paper used in high voltage power transformers, focusing on sustainable approaches in electrical installation. Next lecture was presented by Professor Brijesh Parekh, past President, Association of Chemistry Teachers, India, on the topic Sustainability through Circular Chemistry, emphasizing the role of circular approaches in promoting environmental sustainability. Next invited talk was delivered by Dr. Vivek Mishra, Senior Scientist at Helmholtz Center of Infection Research, Germany, on mechanism-driven synthesis as a design tool for medicinal chemistry, highlighting innovative approaches in drug design. Next invited talk was delivered by Dr. Abhinanda Srivastava, University Department of Chemistry, Bhimrao Ambedkar University, Bihar, on coordination compounds as an operative tool in medicine, emphasizing the medical applications of coordination chemistry. The last invited talk was delivered by Professor Ramkumar Tiwari, Professor and Head, Department of Physics, BSME PG College, Lucknow, on the topic Decoding Transition for a Green Future, the scientific quest for eco-friendly cultural materials. Approximately 250 research papers were presented in both online and offline modes by research scholars, academicians, industrialists across various technical sections, which were chaired and co-chaired by different subjects experts from, I would like to just summarize, Professor Malanath from IIT Roorkee, Professor Sangeeta Bajpayee from Pandit University, Dr. Tahmina Khan from Integral University, Dr. Devendra Mishra, Rajkee Engineering College, Ambedkar Nagar, Professor Prabhat Parvat from Wilson College, Mumbai, Dr. Nilet Tiwari, Gautam Buddha Government Degree College, Professor Rekha Rani and Professor Shiv Kumar Mishra from Amarkantak Tribal University, Dr. Naresh Shukla, Chhatrapati Shahuji Maharaj University, Kanpur, Dr. Amrit Krishna Mitra, Rani Lakshmani University, Dr. Anil Patil, University of Mumbai, Dr. Archana, Dr. Niranjani from KKC College, Dr. Niharika from KKB College, Dr. Mithilesh Yadav from Veer Bahadur Singh University, Dr. Nitesh Jaiswal from Veer Bahadur Singh Purvanchal University, Dr. Pankaj Kumar from Paran University, Gujarat, Dr. Purnima Kushwaha from National PG College, Dr. Virendra Kumar from Firoz Gandhi College, Dr. Shashi Bala from University of Lucknow, Dr. Vishal Singh Chandel, Rajkee Engineering College, Ambedkar Nagar. I apologize if I am not mistaken, I have not taken the name of anyone else. I apologize for that if I forgot. Major Manmeet Kaur Sodi ma'am, the one and the only one. She has also presented the Now let's come to the valedictory session. As we all know, sir is present with us. The presence of Professor Ajay Kaneja sir, Honorable Vice Chancellor and the Chief Guest, and that added immense prestige and insight to the valedictory session. Dr. Anuj Kumar Sharma sir, that has added immense prestige and insight to the valedictory session. Finally, because the sessions got delayed, so we are still waiting for the results of the technical best oral presentations and best poster presentations. So I hope by the end of this session, we will be able to declare that. We will be giving 3 best oral presentations and best poster presentations in the offline and online mode separately. Finally, the conference witnessed enthusiastic participation from subject experts, academicians, researchers, students from India and abroad in both online and offline modes. The conference successfully provided an interdisciplinary platform to deliberate upon sustainable development through chemical sciences and reinforced the collective responsibility of academia towards building a sustainable future. Finally, it became a great success with the wholehearted and tremendous support from our principal, Professor Manjula Upadhyay, ICBDC coordinator and the co-convener, Professor Sangeeta Gondwal ma'am, co-convener, Professor Manjulukta ma'am, co-convener, Professor Sushma Trivedi ma'am, organizing secretary, Dr. Mamta Agarwal, Dr. Sunita Singh, Dr. Chandan Maurya, the core committee of the conference, and the entire Navayugt family. And I'm really thankful for the wholehearted support that because of that, the conference has become a great success. Thank you. Thank you so much. Jai Hind.
Thank you so much, Neha ma'am. We have another learned person among us, Dr. Neeraj Shukla from the KMC Language University. I would like to request Ashna Sinha ma'am to do the honors for him. Sir, please, can you please stand? Thank you. Thank you so much.
The faculty and the students, scholars who have presented the papers in this conference, and the students of this institute. Thank you so much everybody for inviting me to share what actually we are doing and what we have done, and thank you for a brief introduction. So it means a lot for me. Actually, when I was coming to this institute, so this is my first visit to this particular area. Actually, for last 10 years, I have never come to this particular place. So today it was the first visit, and I was wondering that where are we going? And it is a wonderful campus I have seen. So the topic of the conference is bridging disciplines through chemical science for a sustainable future. So chemistry has a vital role in everybody's life, starting from the chemical interference and the cohesiveness of different salts while we take when we got ill, or the chemistry between the husband and wife at the home. So it is very, very important, the topic and the field where all of you are working, and you all are, the part of, or you deserve the congratulations to be part of this particular field. So I am not from this particular field, but I am also working in the area relevant to the chemistry, where I am working with the machining of materials under different environments. So we see the compatibility of the cutting fluids with the workpiece material, the interference, and the impact of the cutting fluid on the machining material. So thank you, ma'am, for inviting me. And I would like to let you know that the university, Dr. APJ Abdul Kalam Technical University, is also working in the field of innovation. A lot of things, because you have presented your work. Sometimes what happens, we have very strong ideas. We have presented in the open platform, but we are not aware what actually the value this particular idea has. So ideas are one of the strongest, they have the strongest value in the world. So if I can have a very strong idea with a high value, commercial value, so it can, give me the strength for entire my future. So just to protect the ideas, so we also running one Kalam Patent Center in the university. We have a strong ecosystem. We are catering the ecosystem of the state as well, because the nodal agency why I am sharing all these things, because you should know, because you are the researchers, you are doing some innovations in your field, so you should know how to protect your ideas, how can we take up those ideas to protect them, and can we convert those ideas into the commercial values. If any idea has commercial value, it means a lot for everybody. So sometimes what happens, one idea can be converted into $1 million, the company. So IT Electronics Department is a nodal agency from the UP government, and we as a university is working together with the IT and Electronics Department. We have catered the startup policy of state 2020. We have given 150 crore rupees to the government just to cater, just to support the startups of the state. So if any scholar, any student, any faculty member want to start their own startup, so we also have made provision of that in our startup policy. So because it was the questions from the faculty member side, so why should we invest our time to improve or to mentor a student? After some time, student can start their own company, they can be billionaire, but what can he get out of this? So we have made a provision in our startup policy that any faculty member, any staff member, if they have any idea, they can work with the student, that they can be one of the co-founder of that company. So you should also have that particular provision. You can start your own company, and I'm sure, because C.P. Saini sir is here in Lucknow University, so he is also very dynamic and he is very quick in taking decisions. So I think he will very soon, I think we all will start all these kind of things in the Lucknow University as well. So being a very close university to Lucknow University, you can take benefit of the AKTU. And we are also running the Startup Ecosystem Innovation Hub. On hub and spoke models, we have different incubation centers where any student, any scholar, any teacher, any stakeholder can visit with their ideas. Their ideas can be converted into the product, and you can file your patent, you can protect your IPRs. So it is my request to everybody, just don't restrict yourself to present or publish your work in the journals only. You should try to convert that literature or that research, if it is possible, to be converted to commercial value or to the patents or to be converted into the product technology, because a lot of companies are looking at the academicians nowadays. So if we can convert our academic, the capability and into the commercial products, so that would be a great help to the industry as well. Because there is a gap between the industry and academia, but now it is day by day decreasing. And I am very happy to hear about the number of papers which the conference conveners has got. 250 is a big number, and for 2 days presenting and coordinating the entire nation, because they have the participation from many states, including the government and private partners. So really the entire team is, I would like to extend my congratulations to entire team under the leadership of I wish you all very best, and I request everybody to keep that fire on in your heart so that you can contribute in the state economy, in the nation economy. So thank you so much. Jai Hind, Jai Bharat.
Thank you so much to our own startup as a co-founders. So sir is here. You can connect with the convener if you want to start any startup. We will tell you all the startup policies, and yes, you can also be a co-founder, a co-owner of your own ideas. It's just need a kick. Thank you so much sir for being here. Now I would like to request Professor Ajay Tancha sir, who is also a subject expert, who is a chemistry expert. Sir, please raise the event.
Thank you, ma'am. Very good afternoon to all of you. Respected Professor Manjula Upadhyay, Principal of Navyog Kanya Mahavidyalaya, Lucknow. The guest of today's function, Dr. Anuj Kumar Sharma, who is a faculty in Center for Advanced Study in AKTU. Dr. Neha Agarwal, Dr. Meena of this international 2-day seminar, organizers, faculty members of this college, and dear students and delegates. It has been a pleasure of visiting this college in a seminar which has been conducted on a very important topic, which stands as Bridging Disciplines through Chemical Sciences for a Sustainable Future. See, there are two big terms here. One is bridging disciplines and second is sustainable future. When the word sustainability is not new to us, even if you see our constitution, we had 42nd amendment in 1976, way back in 1976, where this term was introduced into our constitution, and it has been said that all our policies for the future will be based on sustainable growth. Our Niti Aayog now, which is earlier being Planning Commission, has been talking about this term earlier also, and we have been moving ahead towards Viksit Bharat 2047 with this thought in our mind, with these conditions which are already preconditioned in our mind. Now the biggest what I find is the key point of this seminar was where more than 250 research papers were presented. So the organizers delivers a lot of congratulations for that, because it is not easy to do that in 2 days. And when you are sitting in a validatory function, तो मेरे को बोला गया थोड़ा हिंदी भी बोलना है, तो ये बिल्कुल ऐसे ही होता है कि विदाई होने वाली है और वैलिडिटी फंक्शन सब थक चुके हैं, और इस क्योंकि 2 दिन का कितना प्रयास रहेगा, उसने 2 दिन का नहीं, उसकी तैयारी में 6-7 दिन लगे होंगे और उससे पहले से तैयारी हो रही होगी। तो ये होता है कि किसी तरह सब लोग जाएं तो रेस्ट मिले, और फिर मैडम से भी रिक्वेस्ट करेंगे कि कल की छुट्टी दे दीजिए। लेकिन मैडम आपकी बहुत स्मार्ट है, उन्होंने कल संडे है, उन्होंने वैलिडिटी सैटरडे को रखा है। So coming to the point, see, here again I was talking about sustainability. Sustainability is not new to us. We have been talking about it. लेकिन यहाँ पे जो catch point है कि what is the role of chemical sciences? That is the catch point. And to tell you, as already mentioned by Anuj, that even when we get up and when we go to sleep, we have about 12 hours active working and more than 12 hours of rest. There is no single process known up to date where chemistry is not involved, directly or indirectly. Whether we eat food, whether we wear clothes, whether we do toothpaste or we take bath, even water, we drink water. Water is defined by a chemist. When I remember one joke, the formula of water is H2O. If some chemistry students are sitting here, they know that. अब ये H2O तो बताया गया क्लास में केमिस्ट्री टीचर द्वारा, अगले दिन वो फिर आया तो बोला कि फॉर्मूला बताइएगा H2 वाटर का, तो उन्होंने बोला HIJKLMNO H2O। So ये interpretation है, but again coming to the point, chemical sciences has been the central science which we know. As I told you, there is no single process. Even the oxygen you breathe, the carbon dioxide you exhale, is all defined by chemistry. And it has been a central science and has given to many disciplines. To talk about nanochemistry, to talk about nanotechnology, to talk about material science, to talk about biochemistry, biotechnology, all are related with chemistry, because chemistry being a basis science, and then when it becomes an applied science, it has been given certain names. But we cannot ignore chemistry. We cannot neglect chemistry. So the emphasis was correct in your topic, that if you really want to have a sustainable growth, then chemistry has to play its role. And chemistry is playing its role in a very vital role. It has in a very important, you can say it has a role in all the disciplines. To talk few, that we have greener technologies these days. We talk about green chemistry. What are these? We talk about, there are certain posters which are being pasted here by the students, they talk about good, efficient catalysts. Now what do these catalysts do? In whatever reactions they have been put, they make it more efficient. The reactions become more efficient, so you have a more productivity. So, in a way, how does it has a relationship with the sustainability? Because you are using less energy, so you are saving the environment, because thermodynamics third law says that, or all the three laws says that whatever you are producing, you have to spend some energy for it. And energy comes at a price. Energy comes as a destructive to environment in whatever way you produce it. Just leave ahead nuclear energy. But nuclear energy, if you say the contribution of nuclear energy is less than 4% in our country. So we depend upon thermal, we depend upon solar, we depend upon wind. You must be thinking about why I spoke about solar. Okay, solar panels are there and India is using solar energy a lot and it is a green tool, no problem. But the problem which we will be facing after 15 years when these panels will be discarded is a big question, is a big challenge to all of us. So that is the point where we have to focus upon and where the chemistry will play its role. And the term which we are using for those things is circular economy. So circular economy starts with a very small raddiwala which comes to our house and we sell our newspapers, we sell our cans, we sell our bottles and whatever is useless in our house. But for him it is not useless. He earns his living by circulating it or giving it to a person where he recycles it, which can be again reused. So this is how the circular economy has started its roots, and now we have many industries which are being put to use these useless things and make them into a useful thing, where we don't have to throw them into sea, we don't have to throw them into river, we don't have to dispose in the soil. Very good example, I am remembering it. We all drink Coca-Cola, Campa-Cola, and there was a very hue and cry about few years back that pesticide was found in Coca-Cola. We are all drinking cold drinks and children are fond of it. So what happened? Coca-Cola never put pesticide in its drink, but the water which they were withdrawing from the ground, the pesticides were put by the farmers in an appropriate manner. So they were putting in more pesticide which was required, so it was seeping in and reaching the groundwater, and the groundwater being taken by the Campa-Cola factory or a Coca-Cola factory, and the pesticide was found in the Coca-Cola. So it's a circular economy which plays its role, whether in a natural way or whether in an artificial way. So chemistry has a big role into it, that how to control it. Now we have biopesticides coming into role. So this is all being done by the chemistry people. Now, talking to the delegates here, science must move beyond isolated research. This is what this conference is about. When you move from your labs and goes into industry, then you have an applied science where chemistry plays its role in many fields. Now I would like to give you one example here, that we talk about different types of innovations. We talk about different instruments being manufactured. Let me give you one example of NMR. Everybody must have heard about it, nuclear magnetic resonance. The discoverer of that NMR was physicist. He was an American physicist and he got Nobel Prize for it. The first applicants were chemists for that instrument. chemistry people use it for solids, use it for liquids, and two of the very famous chemists got Nobel Prize for using or applying NMR for various applications which were sustainable. Now the latest thing is, now biologists are using NMR and we call it as now as MRI. You go to some doctors, if you are ill, doctors ask you to just go and do MRI and come with the report. So MRI is nothing but NMR, where you are again monitored for hydrogen, that is proton. And now the latest Nobel Prize in this field was given to a biologist. So what I want to say, it has to be an interdisciplinary research for an application which was discovered by a physicist, applied by the chemist, ultimately used to humankind by the biologist. So this is how the science moves. This is how the science moves. And we have to go with it. So friends, don't feel shy to collaborate with a statistician or collaborate with a physicist, even if you are a chemist, or collaborate with a social scientist. Because ultimately, when you do something, it can be utilized by a physicist to build a technology. And it has been said, today's science is tomorrow's technology. It's a well-known fact. Now coming to Sustainable Development Goals, which is again linked to it. We have about 17 UN Sustainable Goals. And chemistry has a very strong linkage with many of the goals like good health, which is SDG 3. Similarly, clean water, SDG 6, clean energy 7, sustainable cities 11, responsible consumption, that is 12, and climate action 30. There was one poster here which was on climate action. So everybody is facing it and nobody wants to now live in Delhi, where it has every facility of commuting, for studying, jobs are there. But what about the air, which is not conducive for our health? And friends, you all must be knowing it, but just to remind you, if you have a glass of water which is dirty, you have a choice to replace it with a fresh water. But if you have air in this room which is being contaminated, can you change it? No. You cannot change it. You must be saying that we can always put mechanical air ventilators. But what is the price you are paying for that is a big, big question. So it doesn't talk about it on lines with the sustainability. So this you have to see what you are actually doing it for the environment. So you have to, when you grow up, you have to take these challenges, and these challenges cannot be solved by a chemist or a physicist or a biologist, but it has to be a pool of scientists which belongs to different streams. Then only it can be solved. Then if we talk about integration of Indian knowledge systems, then traditional knowledge for which our country is well known, and we are also talking about this in many, many platforms. Then modern science, they can always complement each other. And sustainable practices are rooted in our culture. That is why when we used to do हवन जब हम करते थे, अगर उसको आज भी हम ठीक तरीके से करते हैं जो हमारे वेदों में रखा है, तो it purifies the air. लेकिन क्या है कि हम लोग शॉर्टकट करने लगे, इतना हमारे पास समय नहीं है. हमारे पास हम लोग बोलते हैं चलो गाय का घी नहीं मिल रहा तो कोई भी डाल दो. तो इस तरह की चीजें जब होती हैं तो उसका पूरा फायदा हम लोग को नहीं मिलता. तो these are all things because herbal chemistry is a well-known field which has been there for many ages. And if you see the history of the modern pharmaceutical industry, then what America did was, what was there in our ancient literature, because all medicines were synthesized or extracted by the plants. Our Ayurvedic was very strong. So what American chemists did was they isolated that product, and after isolation they built it or they synthesized it in an artificial manner. When they synthesized it in an artificial manner, it became a medicine. So there was a price war because it is an industry. So there was a price war, and to increase the yield, they started doing malpractices. Even they roped in some doctors who were giving prescriptions which was not required, and very beautifully explained by this girl when I visited her poster. She has mentioned that when you take excess of antibiotics, because you don't have choice, you don't argue with your doctor. A doctor in India doesn't give you much time. नब्ज पकड़ी 10 मिनट में रखा क्योंकि बाहर भीड़ है, उसकी भी गलती नहीं है. Because we have less doctors if you count it per population. But when you start using more of medicines, then your body becomes immune to it. And now you require more dose. We have seen COVID. We have all survived COVID phase. That is why we are all sitting here. What happened to our body? Still we are debating about it, about the medicines, about the injections which were given to us. So it has to be a sustainable development, and sustainable sees, again I am repeating it, the term sustainable means when you use those things which can be again used in future and it remains there for future generations. So all these three things is very difficult to maintain, but still people are working on it, and chemistry has a lot of role to it. Now let us talk about the smart cities which government is building. We have now 100 smart cities coming in India. Lucknow is one of them. But I don't know, you must be facing, I also face daily the traffic chaos which Lucknow has. So can't we have smart, you can say, smart roads, smart governance, smart standards for the smart cities which we are planning? If we can have smart standards for every city which we are planning, then I don't think so much is required for it automatically becomes sustainable growth, which is not there yet. Though we talk about it, we think about it, we discuss about it, but it is not there. This is my point to be noted by the youngsters, because it is you who will be leading various agencies in future. Now coming to the environment and climate studies, we do talk about ecosystem restoration and climate mitigation strategies and sustainable urban development. I was talking to the guest of honor today, Dr. Anwar, and he was saying he works on machine learning. And machine learning and AI is nothing but different patterns of data which can always predict the data in the future. So all of us should use these types of tools to have a better vision of the work which we are doing, which can be used in the future, and that becomes one of the key factors for the sustainability achievement. So everybody should move towards the latest technologies. This is one of the points I want to mention here. Then another point I would like to mention is the behavior change which we should make. And the example which I am remembering right now is Prime Minister Ujjwala Yojana. We distributed LPG gas cylinders to many people. Many people, and lakhs of people got it. The first cylinder. But if you see how many have gone for refilling the second cylinder is a very big question. So why can't we have policies which are again sustainable to the environment, which are again sustainable looking at the different multilingual diversity, cultural diversity and income diversity which our country has. That is another point which you must have pondered during these 2 days of discussion. So, I would not like to take much time. I think I have taken more than what has been assigned to me, because this is one of my favorite topics. I can keep on talking about it. But friends, sustainability is a shared responsibility. It's not question of one man acting, or we can always put it on blame on our government. So it has to be a behavior change, it has to be a technological change, it has to be a scientific change. So chemistry is the connecting thread between them. This is what I want to say. And friends, collaborate, and collaboration is the key of your future success. Young researchers must think beyond your disciplinary boundaries. Not only limit yourself to chemistry, not limit yourself to physics, not limit yourself to biology. Please interact with each other, then only good innovations and incubation should come. So in the end, when chemistry bridges disciplines, it transforms knowledge into sustainable action. This is the message which I want to give, and I would like to thank Principal Manjula Upadhyay, convener Dr. Agarwal, for calling me here and giving me the chance to interact with you all. My best wishes are with you, and I hope the delegates who have stayed in Lucknow must have enjoyed the hospitality and the good food and the culture of Lucknow, which Lucknow always offers. Jai Hind, Jai Bharat.
जिसको हम भाषा विश्वविद्यालय के नाम से जानते हैं, उसके ऑनरेबल वाइस चांसलर हैं और उन्होंने हमें अपना कीमती समय दिया और बहुत ही सरल सहज व्यक्तित्व हैं। मैं सर को पर्सनली इनवाइट करने नहीं जा पाई थी और कन्वेनर्स और को कन्वेनर्स गए थे, उसके बावजूद सर ने हमें सहज रूप में स्वीकार किया नवयुग कन्या महाविद्यालय में आने के लिए। तो एक कॉलेज के लिए, एक यूनिवर्सिटी के बीसी का आना बहुत ही सौभाग्य की बात है, वो भी इस सहजता से। तो मैं आपको हृदय से आभार प्रकट करती हूँ। और जब हम लोग गेस्ट की लिस्ट बना रहे थे तभी ये बात हो चुकी थी कि क्योंकि वाइस चांसलर के रूप में जब डिपार्टमेंट ऑफ केमिस्ट्री ये सेमिनार करा रहा है तो उसमें मोस्ट सुटेबल वैलिडिटी सेशन में हमारे मुख्य अतिथि आप भी हो सकते हैं, तो इसके लिए बहुत बहुत आभार आपका। प्रोफेसर अनुज कुमार शर्मा जी, मैं वैसे क्षमा भी चाहूंगी क्योंकि आपको लास्ट में हम लोग ने परेशान किया, पर मैं आपको बताना चाहूंगी कि अभी कुछ समय पहले ही हम लोग आपके स्टार्टअप इनोवेशन सेंटर गए भी थे और बहुत अच्छा कार्य हो रहा है। साइंस की फील्ड से जहाँ पे ज़्यादा इनोवेटिव चीज़ें हो सकती हैं उनके लिए बहुत ही बेहतरी के लिए AKTU का ये सेंटर काम कर रहा है। तो दो वेल एस्टैब्लिश्ड एकेडमिशियंस जो इंडस्ट्री से भी कनेक्ट करते हैं, सोसाइटी से भी कनेक्ट करते हैं, एकेडमिशियन होने के साथ साथ, तो ऐसे दो कीमती हीरे कहूँगी मैं हमारे बीच हैं और आपने
उनके उद्बोधन में ये चीज महसूस की होगी। और ये वाकई में लग रहा था कि अगर प्रोफेसर तनेजा सर बोलना चाहे तो बोलते ही जाएंगे, और उनको इतनी नॉलेज है उस पर। और मैं एक बार पहले भी मिली हूँ जब सर नए नए शहर में आए थे। अब इतने दिनों में शहर की खूबियां भी सर ने बताई आपको। तो और अनुज कुमार जी तो मुझे लगता है यहीं से हैं। अच्छा, पर फिर भी सर कह रहे थे कि 10 साल हो गए और आप इस क्षेत्र में नहीं आए, तो मतलब आप हमें थैंक यू कह सकते हैं कि आपने ये समय, पर हम लोग आपको बहुत थैंक यू कि आपने हमारे जो यहाँ पे रिसर्चर्स भी हैं, स्टूडेंट्स भी हैं, फैकल्टी मेंबर्स भी हैं, जगह डिफरेंट यूनिवर्सिटीज से हैं, कॉलेजेस से हैं, स्टेट्स से हैं, जो बाहर से आए थे वो तो लोग अभी एक्सप्लोर करने यूपी को गए हैं, प्रयागराज गए हैं। तो आपने इतनी सहजता से अपनी बात रखी, और मैं चाहूँगी कि आप भविष्य में आप हमें समय दें तो हम स्टार्टअप पे या जो IPR पे किस तरीके से लोग अप्लाई कर सकते हैं, तो ये हमारे फैकल्टीज को पता चले। क्योंकि रिसर्च तो सभी कर रहे होते, जैसे कि 250 पेपर प्रेजेंट किए गए, पर उस वो 250 पेपर्स प्रेजेंट करना, फिर उसको मूर्त रूप देना कि वो छपने लायक हो जाए, और उसके बाद आपने जो सजेशन दिया कि हम उसको कमर्शियली वायबल कर सकें, तभी वो यूजफुल होती है रिसर्च। मैं इकोनॉमिक्स फील्ड की हूँ, तो थोड़ी बातें कल से बोलने का मौका नहीं मिला है मुझे, तो ज़्यादा नहीं बोलूँगी। जैसे सर कह रहे थे कि विदाई का समय कोई किसी को सुनना नहीं चाहता, पर ये इकोनॉमिक्स से भी बहुत जुड़ा हुआ है केमिस्ट्री। जब हम ये ब्रोशर शेयर कर रहे थे और ऊपर लिखा था डिपार्टमेंट ऑफ केमिस्ट्री, तो हर किसी का प्रश्न ये तो केमिस्ट्री का है मैडम, हम क्या करेंगे। फिर हमने कहा सब थीम्स पे तो जाइए, हम इतनी जल्दी में रहते हैं हर चीज की कि हम उसको विस्तृत रूप में समझना ही नहीं चाहते, देखना ही नहीं चाहते। अब सोशल मीडिया और इतने टेक्निकल होते चले जा रहे हैं, जैसे AI की और सबकी बात हो रही, उसके कुछ दुष्प्रभाव, जैसे अभी केमिकल मेडिसिन के दुष्प्रभाव एक छात्रा ने अपने पोस्टर के माध्यम से बताया, और जो सर ने भी उसको आगे एलोबरेट किया कि जब हम ओवर मेडिकेशन कर लेते हैं तो हमारी बॉडी इम्यून हो जाती है उन मेडिकेशंस के प्रति, और वाकई में जब हम सीरियसली बीमार पड़ते हैं तो डॉक्टर्स खाली ट्रायल एंड एरर करते रहते हैं। और सर अभी कह रहे थे कि यहाँ पे डॉक्टर्स की कमी है, पर सर डॉक्टर्स की कमी तो है जितनी पॉपुलेशन उस हिसाब से, और थोड़ा एथिक्स की भी कमी, और एथिक्स हर फील्ड में थोड़ा कमियां हैं, और शायद इसीलिए जो है जो डिलीवरी होनी चाहिए वो नहीं हो पाती। फिर भी हम खाली मतलब नेगेटिव साइड तो नहीं देखेंगे, क्योंकि पॉजिटिव साइड ये है कि हमारे साइंटिस्ट ने, हमारे रिसर्चर्स ने कोविड जैसी विषम परिस्थितियों से हम सबको निकाला है। अब जब जान पर बन आती है, जैसे आपको अगर आगे नदी हो और एक तरफ खाई हो, आपको लगता है आप नदी में कूद कर बच पाएंगे, तो आपको तब ये नहीं मालूम होता है, एहसास नहीं होता है कि खाई में गिरेंगे तो क्या होगा, तो आपको बेटर ऑप्शन नदी लगती है तो उसमें आप कूद जाते हैं। तो अब हम उसको एनालाइज कर रहे हैं कि कोविड की जो हमने मेडिसिन ली, जो हमने वैक्सीन ली, तो उसका ये साइड इफेक्ट है, उसका वो साइड इफेक्ट है, पर उस समय तो जब जान पे बनाई थी तो हमारे पास वही ऑप्शन था, तो कम से कम बच गए हैं, तो ये सोच पा रहे हैं और ये दोषारोपण भी कर पा रहे हैं। बाकी इकोनॉमिक्स और केमिस्ट्री का एक जो ब्रिज करने की बात है, और डिसिप्लिन्स की बात अलग है, पर अगर मैं देखूं तो फार्मास्यूटिकल इंडस्ट्री जो हम कह सकते हैं पूरे विश्व को चलाती है आज के समय में, और क्योंकि सबसे एनरिचिंग, सबसे ज्यादा मार्जिन वाली इंडस्ट्री फार्मास्यूटिकल इंडस्ट्री है, तो जो दशा तय कर सकती है विश्व की, खाली एक देश नहीं विश्व की, और उस पर भी कई रिसर्चेस हुई कि क्या कोविड क्रिएटेड क्राइसिस थी, चाइना की लैब में सृजित हुई क्राइसिस थी, या क्या था, वो भी केमिकल्स, मतलब एक लैब में ही सारे टेस्ट चल रहे थे और उसने पूरे विश्व को हिलाकर रख दिया। तो केमिस्ट्री, जैसा कि सर ने भी कहा कि हम जब सुबह सोकर उठते हैं और जब हम सोने जाते हैं तब तक केमिस्ट्री काम करती है, पर मैं तो ये कहूंगी कि जब हम सो रहे होते तो भी केमिस्ट्री काम कर रही होती है। वो हमारी बॉडी एक तरीके से अपने आप को नेक्स्ट डे के लिए रिचार्ज कर रही होती है। बहुत सारे केमिकल चेंजेस बॉडी में हो रहे होते हैं। कभी हम बहुत खुश महसूस करते हैं तो उसका भी एक, जैसे आज सब कुछ सफलतापूर्वक संपन्न हुआ तो हम खुश हैं, तो हमारे कुछ अलग हार्मोन्स हो रहे होंगे, अच्छे खुशी के हार्मोन्स, तो वो भी एक केमिस्ट्री है। और जब पहले दिन हम बहुत नर्वस थे तो भी वो एक केमिस्ट्री ही थी। और जो बच्चे आजकल डिप्रेशन में जाके सुसाइड कर रहे हैं तो उसमें भी उनकी केमिस्ट्री है। वो अपने जो परिवारों में उनको मिलना चाहिए कि बातचीत हो, कनेक्टिविटी हो, अपनी बात कह पाए। शायद मीडिया युग में वो बातें कह नहीं पाते और वो डिप्रेशन में और जाते रहते। पर मुझे तो एग्जैक्ट केमिकल नहीं पता है, पर मैंने सुना है कि वो केमिकल का ही लोचा है। वो डिप्रेशन में भी जो जाते हैं वो केमिकल लोचा, और मैनिक हो गए तो उठा के पटक भी सकते हैं, वो भी एक केमिकल लोचा है। तो इतनी खुशी वाली नोट पे थोड़ा लाइट मूड में बीसी सर के सामने ऐसे बात कर रही हूँ, पर जो है हम सभी बहुत खुश हैं और हम सभी बहुत कृतज्ञ हैं हमारे सभी अतिथियों के आने से। मैं हार्टिएस्ट कॉन्ग्रेचुलेशंस पूरे डिपार्टमेंट ऑफ केमिस्ट्री को, खास तौर पे डॉक्टर नेहा अग्रवाल। मैं कहती तो बहुत कुछ हूँ, ये करिए वो करिए, और कहीं आपकी बात को उसको मूर्त रूप देने की तरफ बढ़े। वो पहला कदम डॉक्टर नेहा अग्रवाल ने बढ़ाया था और कॉलेज से पहली बार फंड उन्होंने लिया, वो भी सेंट्रल डीएसटी से फंड लिया। और उसमें लगा क्योंकि अब फंडिंग भी इतनी आसान नहीं हो गई है और उसका प्रोसेस भी अभी कॉलेज लेवल पे इतना आईटी डेवलप नहीं है, उसमें भी समय लगा। और तब हम फाइनल इनिशिएटिव ले पाए और उसके बाद ब्रोशर और सारी चीजें हुई। तो मान लीजिए कि करीब करीब 1 या सवा महीने की तैयारी पे एक कॉन्फ्रेंस हुई और 500 के ऊपर रजिस्ट्रेशन हुए, ऑनलाइन भी हुए, ऑफलाइन भी हुए, ऑन स्पॉट भी हुए, और उसमें 250 पेपर्स प्रेजेंट हुए। और उसके साथ साथ काफी स्टेट से लोग आए, काफी कुछ कंट्रीज से भी लोग आए और ऑनलाइन भी लोग जुड़े, उनको हम लोग ने सुना भी। तो इस सब के लिए पूरी टीम को बहुत बहुत बधाई। हमारे को कन्वीनर्स, उनको प्रोफेसर सुषमा त्रिवेदी, प्रोफेसर संगीता कोतवाल और प्रोफेसर मंजू गुप्ता, और इसके साथ पूरी ऑर्गेनाइजिंग टीम को डिपार्टमेंट ऑफ केमिस्ट्री में डॉक्टर सुनीता सिंह, डॉक्टर चंदन मौर्य, डॉक्टर ममता वर्मा, इन चारों लोगों की टीम लगातार लगी रही, पर इनके सपोर्ट में ये पूरा स्टाफ लगा रहा। तो जितनी भी साइंस फैकल्टी है, अक्सर यहाँ कॉलेजेस में क्या होता है कि ऐसा नहीं कि किसी फैकल्टी ने कोई चीज ठान ली तो बस उसको करें, सबको लगना पड़ता है। लिमिटेड रिसोर्सेज में हम लोग उस चीज को मूर्त रूप करने की कोशिश करते हैं, और तब जब अपनी ही कल्पना साकार होती है तो जो आंतरिक खुशी होती है, मुझे लगता है वो हम सभी को हो रही होगी। सभी प्रकार की कंपनीज थी, चाहे वो रिफ्रेशमेंट कंपनी 2 दिन से लगातार एक बैठ पे खड़े होकर इतने लोगों को उन्होंने भोजन कराया है, जिसका पुण्य आपको प्राप्त होगा। और इसके रजिस्ट्रेशन कमेटी, मतलब सभी प्रकार की जितनी भी कमेटी मेंबर्स हैं, सबको बहुत बहुत बधाई। मीडिया कमेटी को भी बहुत बहुत बधाई कि मीडिया कमेटी जो है काम कर रही। सभी कमिटीज को मैं कहूँगी, अब मैडम मुझे पॉइंट आउट कर रही, स्टेज कमेटी, डेकोरेशन, सारी कमिटीज हैं सब। अगर किसी का नाम छूटा हो सभी को बधाई। पर हमारे, क्योंकि अगर वक्ता तो हो और श्रोता ना हो तो सब चीज खाली लगती है। ये खाली हॉल हो और मैं बोल रही हूँ तो कुछ नहीं अच्छा लगेगा। पर ये हमारे लिए सौभाग्य की बात रही कि बहुत सारे ऐसे गेस्ट हमारे बीच रहे जो कल से आज तक भी हमारे साथ अभी भी हैं। इसके साथ जो आज सुबह से आए थे वो भी हमारे बीच अभी तक हैं। और आप जैसे समृद्ध श्रोतागण, क्योंकि आप पढ़े लिखे या तो रिसर्चर हैं या एक्विजिशन हैं, तो आप सभी को पाकर नवयुग कन्या महाविद्यालय अपने बीच धन्य है। और ये इस सेशन की जो कोऑर्डिनेट कर रही हैं डॉक्टर क्षितिज शुक्ला जी, आपको बहुत बहुत धन्यवाद, बहुत अच्छे से कोऑर्डिनेट किया। सर मैं बताना चाहूँगी कि प्रोफेसर सीमा पांडे, पास में घर होने का हमको ये नुकसान है कि जितनी भी सजावट, नीचे भी बहुत सारा हमने सेटअप किया था इनॉग्रेशन के व्यू पॉइंट से, इन सारी चीज़ों का उन्होंने ध्यान रखा। रात में 11-12 बजे तक भी कॉलेज में आकर उन्होंने देखा कि क्या चीज़ें कैसे चल रही हैं। तो आपको बहुत बहुत धन्यवाद मेरी तरफ से। रात में वीडियो कॉल करके मैं थोड़ी बहुत डांट भी कुछ लोग को पड़ी है, तो उसके लिए सॉरी। और मैं अगर कोई छूट गया हो तो सभी का आभार। और हमारे बीच डॉक्टर नीरज शुक्ला जी हैं, जिनसे कोऑर्डिनेट करके जो प्रॉक्टर हैं भाषा विश्वविद्यालय के, आपको भी बहुत बहुत धन्यवाद। प्रोफेसर राम कुमार तिवारी जी BSMB PG कॉलेज से आज सुबह से आप हमारे बीच हैं, आपका भी बहुत बहुत धन्यवाद। जिनका नाम मैं नहीं जानती हूँ उनको भी बहुत बहुत धन्यवाद। और हमारा जो टीचिंग एंड नॉन टीचिंग स्टाफ का तो मैंने बताया, जो नॉन टीचिंग स्टाफ होता है वो भी दिन रात लगा रहता है, तो उनको भी बहुत बहुत धन्यवाद। और सबसे बड़ी बात, हम जो कुछ भी कर रहे हैं वो मीडिया में न जाए तो ऐसा लगता है यूजलेस है, तो मीडिया बंधुओं को बहुत बहुत धन्यवाद। वो भले यहाँ पे उपस्थित ना हो इस समय, पर यहाँ से छूटने के बाद उनके पास तुरंत न्यूज पहुँचती है और वो छापते हैं। सुबह हमारे संस्करण में दैनिक जागरण नहीं छपा और मैंने तुरंत शिकायत की और तुरंत फोटो आ गई कि मैडम लखनऊ के संस्करण में छपा है। तो मीडिया वालों को हृदय से आभार, क्योंकि उन्हीं से हमारी पहचान बनती है। और हमारे पैट्रन श्री विजय दयाल जी, जिनका स्वास्थ्य ठीक नहीं है तो इसलिए वो आज हमारे बीच नहीं है, उनका भी मैं बहुत धन्यवाद देती हूँ, क्योंकि वो हमारे संरक्षक हैं और उन्हीं के संरक्षण में हम यह सभी कार्य करते हैं। फिर से सभी को आभार, धन्यवाद।
Institutions, let's carry the spirits of the conference forward. The knowledge shared here is just the beginning. I encourage all of you to initiate collaborations, projects, and keep their network alive to drive for industrial and scientific progress. As we conclude, let's remember it's not an end but a beginning, a continuation of conversations, research collaborations, and partnership formed here. May the ideas exchanged during these 2 days inspire action, innovation, and positive change in our respective fields and communities. Wishing you all a safe travels and continued success in your future endeavors. Thank you once again for being a part of this memorable international gathering. The conference is now officially declared closed. I would like to request you all to please